This is Josh White with JW Math Tutoring. Are you looking for 50 of the hardest digital SAT math problems from 2025? Then go ahead and watch this video.
But life is a dream the calculus could never predict.
Okay, so here you have a quadratic equation and it has r in it, and r is your variable, okay, but q, it also has a q here, which is basically just a constant. And you are told that this equation has no solution. What's the largest possible value of q? All right, so the way you would do this by hand is you would get everything over on one side equal to 0. So we're going to go ahead and we're going to subtract over the 8r and also add the 69 to move that over from the right to the left. Okay, now everything's equal to 0. And then we can go ahead and set up the discriminant. B squared minus 4ac. With it having no solution, we want it to be less than or equal to 0. So here's the thing. The b term here, technically, these two things together make up the middle term, or quote-unquote the b term. So really the way you do it is you factor out an r, your common factor, and then you're left with q minus 8. So b is really equal to q minus 8. A here is just the 1, and c, of course, is the positive 69. So if we go ahead and plug that in, you have q minus 8 squared minus 4 times 1 times 69. Again, we need that all less than or equal to 0. You multiply 4 times 69, you should get 276. And then you have still q minus 8 squared. And then you get q minus 8 squared is less than 276. Now, this is a quadratic inequality, so technically, really what we do is we square root both sides, okay, and you get q minus 8 to less than. You can leave it as root 276, or you could just technically approximate it to like whatever, 16.6 for now. And really what's going to happen, like if you think about this on a number line, is you need these values. Like the q minus 8, when you square it, it's obviously going to be positive, and that means you need to be less than 276. So really, you want the values to end up being between negative root 276, or 16.6, and positive root 276, or 16.6. So in other words, if you think about it on a number line, like here's the root 276, here is the negative root 276. Basically, the q minus 8 values are going to be like everything in between here. Okay? Everything that is essentially in between here. Now, to get the actual value of q, you still have to add 8, and you have to do it to both sides. So you end up with something like it's negative 8.6132 less than q less than, just slide over here, 24.6132. So since they tell you q is an integer, the largest possible value for q is going to be 24. So 24 is going to be the answer to this problem, what you would select. Now, just to confirm a couple things, and then I'll show you also how you could do it in Desmos using the slider. So, first of all, so there's the square root of 276, that's the 16.61. And then, of course, if you add the 8 to it, there's the 24.61 for the upper boundary. I mean, the lower boundary we're not really concerned about, but just to confirm, there's the negative 8.6132. You should be able to as well. Let's see if it'll graph this out. Now I have to use x instead of q. Yeah, so see here, if you just take the, like after you move the negative 276 over to the right, and you have q minus 8 squared less than 276. So you can go to Desmos here, and you could just type this whole thing in, solving this quadratic inequality, and you can see right here, basically all the solutions are between the negative 8.61 and the 24.61. So if you don't fully understand how to solve a quadratic inequality, that's fine. You just go to Desmos, type it in Desmos, and you can see right here, these are all the solutions. So what's the largest possible integer value? Well, it's going to be positive 24, and there's your answer. Now, if you want to do the entire thing in Desmos, then what I would do is I would just graph this out. Okay, so I'm going to graph actually y equals left side. I'm going to replace r with q. Excuse me. I'm going to replace r with x. Then I'm going to graph y equals right side. Okay, now I'm going to add the slider for q. Basically, I want there to be no solution, meaning no intersection points on my graph, which as you can see right now, I zoom out, there's no intersection points. They get further apart here, as the x increases. So really, this is the area I'm concerned with. And then you can just slide this. Notice, zoom out, there's still no intersection points, so let's just bump it up to 50. I'll also set the step to 1 because I only want integers. All right, and now, notice, still no intersection points, but they're getting much closer. 23, do they intersect? No. 24, do they intersect? Still no. You can see there's white space between them, but notice when I click to 25, now there are intersection points. There's one here and there's one here. At 25, there are solutions. At 24, there are no solutions. Therefore, this confirms correct answer is 24. Next up, we have basically a radical function with a quadratic expression underneath it. We're given 2 points it passes through, and we want to know basically, essentially m here is an x-intercept, a 0, a root, whatever you want to call it. We want to know what's the greatest, possible value of that. Notice one of these right here, this is already an x-intercept, a 0, a root. So the question is there going to be another one that's greater than 2, or is it going to be less than 2? And if it is, then this would just be our answer. So you can do this one by hand. I will briefly go through it. I'm not going to go through all the work because it is so much faster, quicker, and easier in Desmos. But first, I'll just mention a couple things. First of all, if you notice at this point here, if you set the left side equal to 370 and then plug in 0 for x, underneath the radical, these two terms drop out, so you just get this. So therefore, the c value has to equal 370. Then to find b, you could go ahead and you could just plug in this point. So in other words, 0 equals negative, caught together with the radical. 2 squared plus 2 times b plus 370. And then this you can just go ahead and technically you could first square both sides and it's just 0. And then this is 374 plus 2b. So b is going to equal negative 187. So now you have the full equation. X squared, get rid of this, minus 187 plus 370. Minus 27x, excuse me, plus 370 all under the radical. Okay, so now you just have to find the zeros. Now if you wanted to, you could take this and you could factor it. Again, I'm not going to show all the work because I've already worked it out and know what the answer is. It's so much easier to do this in Desmos. But it's going to factor as x minus 2, x minus 185. And then your x's, your two zeros are 2 and 185. So what's the greatest possible value of m? Well, it's just this right here, 185. Now, a couple things to mention in Desmos. So if you try to do this using regression, you're going to see something unusual. So first, okay, here are 2 points that we have. So if you just try to type it exactly as it is, you're going to run into a problem, and it's because of the square root. Okay, so if you notice here, these are not the correct values. In other words, for B and C. When I worked it up by hand, I got negative 187 and I got 370 for C. I don't know exactly why it's doing this, and you can even see, let's see, the 20 is right here. Notice it goes through 20, but my other point, my 0 negative root 370, it doesn't go through that. This point, that's the point right here in green, and the graph is clearly not going through it. And also notice the r squared value is not 1. That tells me that there's error. It's not, 100% accurate. So something's going on that this is not, that this is not correct. The only way I found to go around this was if I squared both sides. So that means basically get rid of like, actually, let me see. I think when I first did it, I got rid of the square root expression. No, that didn't do it. So yeah, I think I have to do that. So let me, there we go. Okay. Okay, except this, see, so notice here, it's giving me the right C value, but it's not giving me the correct. See, yeah, technically, what you have to do, this is the way you have to, basically you have to square both sides, and that will get rid of the negative here that's in front of the radical. But that's fine, because notice it gives you the correct values for B and C. It gives you negative 187 and it gives you 370. So now what you would have to do though, because notice there's no graph on the screen, okay? Now what you would have to do is you would have to go back and basically retype the equation in its given form, which is with the square root. Actually, we should be able to type plus bx plus c. Okay, yeah. Now it's giving me the actual graph. So now the question is, what's the greatest zero or intercept? Well, it's not 2. It's over here at 185. So that's that's basically your correct answer. And this is kind of the approach or the strategy that you have to use in Desmos because the square root is basically messing up the regression. Now, I will also mention, if you did the first part by hand and you got B and C, of course, then once you got to that point, right, then you just go to Desmos and you type in x squared minus 187x plus 370, just ignoring the square root. We're only concerned with the part underneath it. And then, you got to scroll, and then you can see right here. Here are my two zeros. 2 we already know about. 185 is the one we're looking for. Okay? So you could obviously do this part right here, this second half of the problem in Desmos as well. Worksheet number 2, and we're going to start with problem number 4. Okay, so for this one, there are actually 2 different methods that you could do. One method, which I think I may have talked about in some other videos, is that when you go to do the regression, okay, if you just put it in as it's listed and you put in the 2 points, it doesn't work properly. So there's some workarounds for that. One method, one way to get the workaround is to just type in the C value. So I want to put in 20 here. Okay. So for example, if you notice, if you plug in 0 for x, you take this point and plug it in. This is 0, this is 0. Therefore, you get negative root 370 equals negative c, square root c. Therefore, c has to equal 370. So the first alternate method is just to do the regression as given. But just type in the 370 like this, and now we get the correct answer. And so now we get the correct answer for B, But again, remember what this question is asking for is what's the greatest possible value of m? M is basically an x-intercept because notice h of m equals 0. So we want to know what are the x values that we plug in where this function is 0. Okay, so 2 is the one we already are given and know. Where's the other one? Okay, it's over here at 185. So 185 is the correct answer. Therefore, this is one kind of workaround to solve this. But here is another alternate way you could do this problem, where you could type it in and use regression and get the answer as well. So what we can also do is we can type in both points to the table. And now what I'm going to do for the regression is I'm going to do it slightly differently. I'm going to basically take this and put it in its factored or its intercept form. So I'm going to do x1 minus a and x1 minus b. Okay, so again, notice here, it's still actually not giving us the correct answer or the correct values. So what you have to do is you either have to type in the 2 here for say for A, or technically you could do it for B, it doesn't matter. For one of the intercepts is the point, or you can also define it down here. Notice when I do this now, okay, so it's still not giving me the correct answer. So let's try this. Let's try typing it in instead. Let's get rid of this. There we go. So, okay, it looks like for this method, and I don't know why this is like this. And let me actually try with A, but defining it. Okay, so in terms of typing the 2 in here for one of the intercepts in this factored form versus leaving it as a constant A, but then defining A, as 2, because it's given in the problem right here, it looks like that part doesn't matter. Okay, so that part's irrelevant. So we could type the 2 in here, we could just leave it how it is now. But the key is, for some reason, we can't add the second point to the table when we do the regression. It looks like something messes up with it. We can only use this 0, comma, negative square root 370 point. And so when we do this, notice now we have the correct graph. Basically, you have over here 185, and specifically B is the other x-intercept that you're looking for. So this one's actually a bit shorter, bit simpler in that it gives you the other x-intercept value, i.e. the other possible value of m, and now you can easily compare, well, what's the greatest value? Is it 185 or is it 2? Okay, it's obviously 185. So therefore, that's your correct answer, and this is an alternate way to do this problem. Next up, we have question number 5, and this is actually a fairly tricky question because you are given a function here and you're told it's going to be factored into some form there, and a, b, and c are obviously just coefficients, constants, numbers, integers, and they want to know what the value of a times b plus c is. So the reason that this is a tricky problem is because there are multiple ways that you can start the factoring. In other words, so if you look at this in terms of a is going to be the common factor that you pull out of all terms, right? So you could technically just do a equals 1 and just leave it as it is. You could also do a equals 2. You could do a equals 5, or you could do a equals 10. You can't go anything above that because once you pull out a 10, the 320 turns into 32, and then you can't go any lower. You can't leave a number smaller than that because then you couldn't factor it and have 32 as one of the last numbers in one of the parentheses. Okay? So the thing is, though, then if you're looking to factor it, so you've got basically the original problem, you've got the 2 out front here, and then you're going to have 20 and 120 and 160, and then you have a 5 out here, and you're going to have 8, and let me just make sure I get this correct, 48 x squared plus 64. And if you factor 10 out, you have 4, 24, and 32. Okay, here's where the issue or the problem comes. Technically, only one of these can actually be factored correctly into this form such that when you multiply it out, it meets the original problem. And so just to save time, in essence here, I'm going to show you, I'm going to basically demonstrate this in Desmos. So, all right, so I have the original, right? 40x to the fourth plus 240x squared plus 320. So if I'm going to factor it into this format, okay, first of all, a is 1, that's out front. Okay, and then I have to have an x squared here. Now, 320, it has to be split up into 32 and 10, meaning b has to be 10 because the 10 has to multiply by the 32 in the other parentheses to make 320. Similarly, you have to put a 40 here, okay, and that's going to be c, because 40x squared times the x, just the 1x squared in the first parenthesis has to make the 40x to the fourth. All right, so here's the thing, and I'm going to type the original. Okay, so I'm going to type the original before the factoring. Here's the problem, though. I'm going to zoom out. Okay, so if you zoom in here, you technically will see these two graphs are not the same. Like, they do not overlap. This is the original, and this is how it would have to be factored given the constraints of the problem. So the point is, if you multiply this out, it doesn't equal the original expression. You basically get 400x squared plus 32x squared. You get 432x squared for the middle term, and that doesn't match. So you cannot factor a, or factor like the first option where a equals 1 into that form. And if you try to do it, I'll just try it for one more to show it doesn't work. I'm not going to show all three that don't work. But if you try to do it for the second one, so again, the original thing is going to be with the 2 out front. Okay, this. And now when we go to factor it, okay, we have the 2 out front here. Okay, it's going to be x squared and 20x squared to make 20x to the fourth. And 32 times 5 is what equals 160. So this has to be a 5 here. All right. So now again, if you notice, these two graphs, let me just zoom out and go down here till we get to where the vertex is. Zoom in a ways, they're pretty close, but they're not identical. They do not overlap. You can see there's two distinct colors, on the graph. And again, if you check the inner, multiplying the inner and the outer, 5 times 20 is 100. 32 times 1 is 32. 100 plus 32 x squared does not equal 120x squared. So the point is, these two are not equivalent. So if you pull out a 2, you cannot factor with the remaining expression into this form, okay, where you have a plus 32 and you have just a 1x squared in the front. The only one that works is going to be this one right here. Okay, and it's going to factor as 5x squared and then 8x squared. Just make sure I get this correct. And then it's going to be 32 and 2. And now if you check it, 8 times 2 is 16. 32 times 1 is 32. They add to make 48. That matches this right here. Okay, and we could go to Desmos and I could graph both of them just to show you that like this graph completely overlaps this one, but this is going to be the correct answer. Therefore, A is 5, B is 2, and C, just make sure I get, right here C is 8. So 5 times 2 plus 8, 5 times 10 equals 50. Now, the thing that is actually interesting or unusual about this is even with the other possibilities for A, I believe if you try to factor them out, like if you even if you try to factor them, even though it's not correct, the a, b, and c values are different, but this expression still ends up equaling 50. So even if you chose one of the other ones by mistake, like if you did this last one by mistake, it still technically ends up working out to 50. I don't know why they set it up like that. I don't know, why it works out like that, but in any case, I believe for the other three wrong answer choices that technically you can't factor any further, you still end up getting the same a times b plus c value. But in any case, the correct answer for this is 50. All right, now question number 5. There are two different ways you could do this one that I did not see at the time or did not recognize. So thank you to the two different commenters whose names should appear on the screen at various points in order to solve this. The first way is just using regression. I don't know why I didn't think of this or why I missed it, but if we just take the original expression, okay, and we regress that to the given factored form. Okay, so we have this. I forgot the subscript one. There we go. Okay, now we have to define x1 as a list. I'm just going to use a new trick I have now, which is just do random and then 5 numbers. Okay, notice it gives us values for a, b, and c. So what is the value of a times b plus c? Right there, it's 50. This is the entire problem done in, under 30 seconds. So again, gives us the correct answer, which is 50. And what I did is I did regression between the original expression and the factored form. And then once I do that, it finds basically the only possible values of a, b, and c. And then just type them in, or you could just do it in your head if you wanted to. Okay, so that is one method. Now, here's another alternate solution method that you could use as well. This one is basically really not a Desmos method, but it's a different way to think about this. So this is method 1. Okay, an alternate method you could use is you could multiply out these two parentheses on the right. So you have, just using FOIL, cx to the fourth for the first, then for the inner bcx squared, for the outer 32x squared, and then the last is 32b. Then you go ahead and you distribute, a to every single term. All right. Now, what you're going to do is you're going to match up the original expression and, basically the coefficients. So we know that 40x to the fourth matches up with acx to the fourth. We know that 240x squared matches up with these two terms. And we know that 32b matches up with 320. All right. So, excuse me, I just noticed a mistake. This is not 32b. This is 32ab. Okay, so now at this point, if you notice, the expression we want is a times b plus c. However, if you multiply this out, it's really ab plus ac. And now we actually know what the values of each of these are. Okay, notice from the x to the fourth term, we know that ac is equal to 40. Therefore, we can plug that in. And notice from the last term, ab is equal to 320. Therefore, ab has to equal 10. 32 times 10 would be 320. 10 plus 40 equals 50. So this is just an alternate approach you could take instead of using Desmos. Probably a little bit more work and probably longer than using Desmos, but again, completely valid solution method. All right, last, let's look at a problem involving some similar triangles. Question number 10 here. So we have two right triangles. Here is, let's see, A, B, C. B is our right angle. And then we have a larger one, D, E, F. E is our right angle. That's given. Okay, every side in DEF is 2.7 times corresponding side length in ABC. So tan F is 9 over 40. So that means you'd say the opposite side here is 9. Here's angle F. And the adjacent side is 40 from SOHCAHTOA. Tangent opposite over adjacent. Okay. The quickest, easiest way to do this is to note that since when you have similar triangles, the angles themselves are congruent. So angle C is congruent to angle F. What that means is the cosine of C will be the same value as the cosine of F. So what's the cosine of F? Well, cosine of F is just adjacent, which is 40 over the hypotenuse. Well, I don't know the hypotenuse, but I can use Pythagorean theorem to find it. 9 squared plus 40 squared equals C squared. This is an example where I think using regression Desmos is so much quicker and so much easier because you can literally just type 9 squared plus 40 squared, then the tilde, C squared. Okay, so C, the hypotenuse, is 41. Therefore, cosine F is 40 over 41. That means cosine C is also 40 over 41, and that's our answer. So note, if you want to put it as a decimal, there's like multiple different ways you can put it. You could put 0.9756. That's 5 total spaces. You could put 0.976 if you round. You could put 0.975 if you truncate. So again, all of these would be considered correct as well. Now, an alternate approach to this, which is a little bit more work, takes a little bit longer, you could figure out the actual side lengths for ABC. So like, let's say you used Pythagorean theorem and you found this is 41, and then you notice, okay, every side in like basically DEF equals 2.7 ABC. So that means each side in ABC is smaller, and specifically the way you get it is you divide the 9, the 40, the 41 all by 2.7. So you could just go into Desmos, and you could just say, okay, 41 divided by 2.7. Well, it's whatever. 15.185, blah, blah, blah. And then you could also do 40 divided by 2.7. 14.81. Again, I'm going to use the exact values. I'm just writing these down as like, temporary things. 9 divided by 2.7. 3 and a third. 3.3 repeating. So once you have these, then you could say, all right, cosine C equals adjacent over hypotenuse. So notice, the adjacent is the 40 divided by 2.7. So I'm going to call this A just for the adjacent. And the hypotenuse is the 41 divided by 2.7. So I'm going to call this the hypotenuse. So I'll just define this as H. Okay, and now I can say, I know that cosine C is just equal to adjacent over hypotenuse. And notice I get the same decimal here, but because I defined A and H as the exact values, if I click this, it gives me the nice 40 over 41 if you want to enter it in fraction form. So this is just an alternate approach if you actually wanted to find the exact values for every side in ABC and then calculate cosine C from there. All right, next up, let's look at question number 3 here at the bottom of the page. So here you have an expression, basically it's a rational function. They tell you that this graph does not touch the line x equals 3. I don't know if that's the exact wording they used on the test. I mean, that's what people mentioned. But in any case, what this means is that there is a vertical asymptote. So if you graph this out at x equals 3, there will be a vertical asymptote. The graph, whatever, would look just hypothetically something like this. So that means that the denominator basically is going to equal 0 when x equals 3. Meaning that when you plug 3 in for x, you get a 0 in the denominator. That's basically what causes this does not touch the line situation, i.e. vertical asymptote, to happen. So you plug in 3 for x, and 6 plus c equals 0. So that's how you know that c equals negative 6. All right. Now, from the numerator part, so you got minus 6 on the bottom. They tell you that both f of 7 and f of 8 are zeros. So there's multiple ways that you could do this. What I think is the easiest way is just to notice, okay, well, if they're both zeros, then that means since this is a quadratic on top, it's got to be x minus 7 times x minus 8 because, these are our two, 7 and 8 are our two x-intercepts, our two zeros, two roots. So you multiply this out, you get x squared minus 15x plus 56. So we've got, so obviously here, this is just 1, and that, notice that matches. But then this is technically our a value, and this is our b value. So a plus b plus c should equal negative 15 plus 56 minus 6. So we go ahead, we add all those together, and you should get 35. So the correct answer for this problem that you would grid in is going to be 35. Let's just confirm. Negative 15 plus 56 minus 6. Yep, 35. All right. Now, could we do this in Desmos? So I believe that you can get the A and B values in Desmos, but for C, that I don't know that there's necessarily any easy way to do that in Desmos. I believe you are going to still have to know that when you plug in x equals 3, basically it makes the function undefined, i.e. the denominator is equal to 0. So this I think you still have to find manually. But let's say you did that, and then you could just make a table. All right, and then we could put in the function. So we're going to have x1 squared minus a x1 plus b, and then divide that by 2x minus 6. Okay, so notice here, okay, it's giving me, let's see, oh, this is the reason. I was going to say it's giving me the wrong a value, but it's because I typed a negative instead of a positive. So always double check, make sure everything is typed correctly. This should be plus here. Now, a plus b, and then technically for c, we would have to do it manually here and, type in negative 6. Unless you wanted to just make this c, and you would, in a separate line, just say c equals negative 6. You could, of course, do that as well. But in any case, that's how you could do regression just to find the values for a and b in Desmos. Is problem number 3, and it is this function here. Make sure I get the whole thing on the screen. Where basically you have a rational function, and essentially there's an asymptote at x equals 3, and you know two x-intercepts here, 7 and 8. Find a plus b plus c. Okay, so what you can do for this one is you can actually do regression, and it's not going to be exact, but it will be close enough that it will still give us the correct answer. So what we can do is we can enter in 3 points. Okay, so we know that 7, 0 is a point. We know that 8, 0 is a point. And now for the third thing, what I'm going to do is it does not touch the line at x equals 3. That means there's a vertical asymptote. So when x is 3, I'm going to enter in a gigantically large number. Just a bunch of 9s, okay? That's going to function essentially the same as a vertical asymptote. So now what we can do is we can do regression with this form of, x squared plus ax plus b on top, and then on the bottom, 2x plus c. Okay, so now what happens is we have a plus b plus, we have a and b and c. It found values for us. What is a plus b plus c? Okay, notice here again, it's not exact because technically it's putting a point in, an actual finite value in for 3 when x is 3, when in reality it's supposed to be infinity, not 9,999,999. But notice it's close enough because if you take this answer and you either round it or truncate it to 5 total digits, it's going to be 35.00 or just 35. which is the correct answer. So this is how you could do this entire problem in Desmos by just simulating the vertical asymptote x equals 3 by using a point for it, with just an extremely high y value here. All right, so with all being said, let's go ahead and get started here on problem number 1. All right, so here we have a rational function with some constants in it. They give us 2 points that it goes through, and they tell us basically one of these points, notice, is an x-intercept, 11, 0, and essentially there's another x-intercept, that the v of q equals 0, i.e. you plug in some value for x, it's going to be 0 as your output. What is this value of q? Where is the other x-intercept happening? Okay, so this one might look complicated, but it actually is not complicated at all, either by hand or in Desmos. So first I'll show you how to do it by hand. Basically, the way to do this is first, notice that if you plug in 0 for x into this whole thing, okay, on the bottom you're going to get negative 7 times negative 17. On the top, this becomes 0, this becomes 0. So you literally just get c. And the output is equal to 99 over 119. Well, if you go to Desmos, you should see that negative 7 times negative 17 is just 119. So in other words, these parts match up perfectly, and c is just equal to 99. All right? So now we know the top is whatever, x squared plus bx plus 99. And here's the other important fact, or the other important thing to remember. So one of the x-intercepts is 11, 0, right? Again, the x-intercepts are the values you plug in for x that are going to give you 0 as your output. That's only going to happen when you get a 0 in the numerator. So we can ignore the denominator for this purpose. Okay? So in other words, we're taking the numerator and we're setting it equal to 0. Now, we know that one of the zeros is positive 11. That corresponds to a factor of negative 11. Or in other words, another way to think about this is, I'm taking my quadratic expression here, and I'm basically putting it in x-intercept form, which is like x minus p, x minus q. One of the intercepts is 11. So now, I just need to find what the other one is in order to give me a 0. So notice, since I know that the c value is positive 99, the number in here has to multiply by negative 11 to make positive 99. So it has to be negative 9. So therefore, the other x-intercept, or in other words, the value of q in this problem, is just going to be 9. So that's it. Basically it factors into x minus 11 and x minus 9 on the top, and then, of course, a factor of x minus 9 corresponds to an x-intercept value of positive 9. So that's just your answer. Now, of course, we could go to Desmos. Let me actually just erase the problem so we can see the full thing here. Let's delete this. All right. So what I'm going to do is, I'm just going to make a table. I'm going to put my 2 points in the table. Okay, then I'm going to do regression. I'm going to do it manually because it doesn't match one of the preset forms. So on top, we're going to have x1 squared plus bx plus c, bx1 plus c. And on the bottom, we're going to have x minus 7, x1 minus 7, x1 minus 17. Okay, we're not honestly concerned about the b and c values here. What we're really concerned about is where are the x-intercepts of this graph. It's really, we're concerned with it generating the graph. Okay, and so if you notice, you zoom in here. Okay, here's one. Here is the other one right here, 9, 0. So we got 11, 0, we got 9, 0. Ignore this. This is just a maximum point that it's making clickable. So this just confirms the other value of q, which has a y value of 0, is positive 9. So this is how you could do the entire problem in Desmos. All right, next up, let's take a look at question number 3. So here you have a quadratic equation, and it has two constants in it, p and w, and you're told about the solutions, that they're basically opposite values of each other, like 10 and negative 10, 5 and negative 5. And they want to know what are all the possible values of w that could be true here. So the first thing I'm going to do is I'm going to get this expression equal to 0. So I'm going to add the px over to the other side, and I'm going to subtract the w. All right, and now I'm going to note that this is a. Technically, b is 112 plus p if you factored the x out as a common factor, and then this whole thing is my c. Okay, the reason I'm identifying that is because we're going to use the product of roots shortcut formula, which is c over a. So, per the equation, that is just 42 minus w over negative 4. Now I can set that equal to the actual product when I multiply w over 2 times negative w over 2, which is going to be negative w squared over 4. Now we can just go ahead and solve this equation for w, and that will give us our answers. So if you can notice, the 4's cancel out, except this is the negative 4, so that technically means that there is a negative that's going to apply to both terms on this side. So in other words, it's going to be negative 42 plus w equals negative w squared. So then if I move the w squared over, I'm going to get w squared plus w minus 42 equals 0. Now from this point, you could just go to Desmos and you could solve it in Desmos, or you can just factor it. It's going to be w plus 7, w minus 6. So w equals negative 7 or w equals positive 6. So there are two possible correct answers you could give for this problem, one right here and one right here. I mean, the thing is, p ends up having to equal negative 112 because the only way you get opposite values like this is technically when the expression can be factored as a difference of squares. And the only way that happens is when the b term essentially is 0. Because if you think about it also, the sum of the two roots is equal to negative b over a, and if you add these together, you get 0 over 2. W plus negative w, 0, it cancels out. Therefore, b has to be 0, which means that the p has to be negative 112. So this whole term in the middle drops out. So I guess I don't know of an exact way, though, to solve this in Desmos if you realize that. Okay, so now, if you do realize that, though, there is actually a shortcut you can use to get the answers in Desmos, and that would be the following. So if you realize, again, you have to realize that p you have to solve and basically get that b is 0 and p is negative 112. Notice then what you're left with is negative 4x1 squared, and I'm just going to use regression here, plus 42 minus w, and we're going to regress that to 0. Okay. Now, we also know, though, that x1, one of the solutions to this, is just w over 2. So notice when I do that, it gives me one of the possible answers here of positive 6. Let's see if I put in this qualifier, and then if I do this, okay, and I say, well, w has to be negative. All right, there's my second answer of negative 7. So that's how you could solve this in Desmos. However, I believe you do need to solve first to find that b equals 0, which then lets you determine that p equals negative 112, or basically that the whole thing cancels out. I guess you don't need to know that p equals negative 112. You just need to know that this entire term drops out, and it's going to factor as a difference of squares. And then once you get to that point, you could technically go into Desmos. You don't need to set up the product of solutions equation. Okay, next we're going to go to worksheet number 4, specifically first up, problem number 3. All right, next we're going to go to worksheet number 4 to look at a couple problems. The first one is problem number 3. So with this one, when I initially went over this, I did not know of a way to solve this entirely in Desmos, but then after I learned about regressing quadratics to their intercept or factored form, this one can actually be done entirely in Desmos, basically, in one step. So what I'm going to do first is I'm going to move these two terms over to the left so that everything is equal to 0. Then I'm going to do regression to its intercept or its factored form. So I get negative 4 x1 squared plus 112x1 plus 42 plus px1 minus w. Okay, now for its intercept or factored form, I know the two solutions or the two intercepts are w over 2 and negative w over 2. So I can just do x1 minus each of them. x1 minus w over 2, and then technically x1 minus negative w over 2, which I'm just going to simplify to plus w over 2. So now, make my list for x1. Easiest way is just I'm going to do 5 random numbers. Notice here it gives me the value for p, it gives me the value for w, it gives me the value for a. I don't care about p or a. Really, I'm only concerned with is w. So it gives me one solution, which is that w equals 6. If you want the other solution, then what we can do here is we can put in a constraint. Let's make w less than 4, and notice it gives me negative 7, which is the other acceptable answer. So again, this is how you can use regression to solve this entire problem in Desmos. Basically, we're taking a quadratic expression and regressing it to its factored or intercept form, and that will find the values of w for us. All right, let's look now at question number 9. So this one, I did not get all the details for it, but I tried to, I think, set it up or work it out as best I could to understand it. So essentially what's going on here is you have two perpendicular lines, okay, and they intersect at some point. Picture whatever looks right, looks like something like this. All right, let's say this is line K. Okay, this is line L. And they tell you line K has a slope of m, and here's the other important point. I'm assuming it told you it's a non-zero value for the slope of m, because if line K had a slope of 0 like this, so in other words, like K was horizontal and L was perpendicular, well, then this question wouldn't make sense because every value for L would just be the line x equals 6. Okay, so none of these points would be on it. So that's why I put that qualifier in there. All right, so now, which of the following points does L pass through? So here's the thing. The slope for K is m. L is perpendicular to that. That means the slope for line L will be the opposite reciprocal, or negative 1 over m. All right? So what that means is, basically, if you think about negative 1 over m, if you think about just like putting this over 1, and then think about this whole thing as the change in y, and then this is like your change in x, because slope is rise over run, change in y over change in x. You're going from 6 to 7. So your delta x equals 1, right? You're adding 1 to move from x value 6 to x value 7. So that means your y value is going to change by this amount. So you're going to take the 3 that you're at originally, and you're going to add to that the negative 1 over m. So the correct answer for this problem is letter A. Now, let's look at some specific examples in Desmos to see how we could just confirm this. So I am going to first just make up a line for K. So I'm just going to do linear regression. I'm going to give a slope of 2, and it has to go, and it goes through this point. Okay? So I could pick whatever slope I wanted. I just picked 2. So notice that this goes through this point and it has a non-zero slope. That's the only thing that's required. So this is line K. Now, for line L, it's going to go through the same point, 6, 3. I'm going to add a new table, though. And the key is its slope is going to be basically the opposite reciprocal of the line K. So in other words, I take 2 and I flip it to make 1/2, and then I put a negative in front of it. Okay, so now I have both lines graphed here. K is the positive slope line, L is the negative slope line. So now I'm seeing, okay, so now I want to see where is the point on line L that has an x-coordinate of 7. So let's just graph x equals 7 and see where it intersects. So notice it's right here. It's at 7, comma 2.5. All right? So 7, comma 2.5. So remember, m was equal to 2. So now I just need to go through all these y coordinates and just plug in 2 for m and see which of these expressions gives me 2.5. So the first one, 3 minus, and what I'm going to do is I'm going to define m here as 2. Then I can just type the expressions with that. So 3 minus 1 over m. Notice, that gives me 2.5. That confirms that's the correct answer, but let's just prove that the others don't work. So notice for b, it's 1 over m, 3.5. Nope. Now for c, 3 minus m, 1, wrong. 3 plus m, 5, wrong. Okay, so that's just an alternate way you could look at this and you could prove it. And the same thing is going to be true. Like, I'll just show you quickly. Let's say I make the slope of line K negative, and now that makes the slope of line L positive. Now, notice the y-coordinate is 3.5. So if I go through my answer choices, again, remember this was negative 2. So now, if I do 3 minus 1 over m, notice it's 3.5. That matches. That just confirms again that A is correct. It doesn't matter also if the slope is positive or negative. It's going to work either way. So let's go ahead and get started here with question number 1. Basically, what we have going on here is a linear function and an exponential function. So f of x is the linear function. 3 to the x, g of x, or excuse me, is the exponential function. G of x is the linear function. And if you are familiar with the properties of each, basically, you know what happens. Obviously, a linear function increases at a constant rate the entire time, whereas an exponential function, you know, will start off with a very, very slow rate of change, and then, you know, eventually it becomes much, much larger. So if you were to, say, graph these out, just to kind of give you a visual of what's going on, basically, let's say you have your exponential function here, you know, slowly increasing, and then it starts to take off, you know, somewhere around here. And then you might have your linear function, which is going, you know, increasing at a constant rate. Okay, this is not, it's going to need to be a little steeper. Sorry to go through this. Maybe something like this. Okay, so these 2 points of intersection, these are H, J, and K, L. Okay, H, comma, J is the first one, and then the K, comma, L is the second one. The reason you know that is because it tells us that J is less than L. Okay, notice J and L are the y-coordinate values. And the reason that it works out that HJ is the first point is because 3 to the x, if you graph it out, and we can confirm this in Desmos, you know, it's just going to be increasing as it goes to the right, and the linear function has a positive slope. Okay. Obviously, this would be different if we had a number basically that was between 0 and 1 for exponential function, and it would say it was decreasing, you know, going down, looking like this. And or the linear function had a negative slope. Okay. So basically, you know, we want to know which of the following statements here is true when f of x is less than g of x. Okay, so f of x is the exponential function. So actually, I should just do this in Desmos. there's no reason to really draw this all out when we can just get a much cleaner visual representation here in Desmos. Okay, so there's f of x. Now, for the linear function, I mean, you do have to actually pick something here. So what I chose is 2x plus 1, and then I will zoom in, and now we have a nice picture right here, okay? So when f of x, which is the red, is less than or below than g of x, which is the blue, okay, which of the following is true? Well, basically it's asking is which kind of region do the x values exist where that happens? In other words, where are the x values for which this is true? So if you notice, h is basically this 0 right here, the first intersection point. K is the x-coordinate of the second intersection point right here, which is 1. So this is true between 0 and 1, or in other words, where where x is between h and k. So the correct answer for this is going to be letter B, 2 only. It's not going to be true for the other two. And just to go back here again. So essentially, x is less than h would be this area over here to the left of, 0, basically the, negative x values. And here you can clearly see that the f of x is greater than g of x. The exponential is greater than the linear. Same thing when you move to the right of k, i.e. to the right of positive 1, the exponential, here is greater than the g of x, or the linear function. So the correct answer for this, when is, which of the following regions is f of x less than g of x? And so the correct answer is just when the x value is between h and k, or in other words, between 0 and 1 for these specific values that I chose. Next, let's look at another repeat question here dealing with the product of the roots for a polynomial equation. So first I'll show you how to do this by hand, then I will show you how to do this using Desmos entirely. So if you're going to do this by hand, you would notice that the various roots we have to multiply are going to be negative 8/5 from the first parenthesis, and then negative root 5 plus k from the second parenthesis, and then positive 5 plus k from the third parenthesis. And the product of all these roots is equal to 72. Again, the way we're getting this, I'm basically just taking each parenthesis and setting it equal to 0 and then solving for x. Okay, so notice a couple things here. First, two negative signs will cancel out and just make everything positive. Okay, so I'm just going to get rid of that. I'm going to get rid of that just so it's not causing confusion and we think something being added when they're really being multiplied. All right, I can also multiply by 5/8 on both sides. So this and this cancel out. On the right side, you should get 45 because 8 goes into 72 9 times. 9 times 5, 45. Next, square root of the identical expression twice, or i.e. the square root of something squared, just becomes that expression. And then we can easily solve this and get k equals 40. So that's the value of k. It's actually not that much work. You can see here to do it by hand. However, we can, of course, do this entirely in Desmos. All right, so what we need to do is the following. We're going to take the original equation that we're given, and we are going to do a regression where we regress it to its intercept form, or basically its factored form. The reason we do that is because it allows us to define the various roots. Okay, so let's put an m out here. And then we got x1 minus a, x1 minus b, x1 minus c. A, b, and c here represent the three roots. You know, and the fact that there's three roots because there's three parentheses. And the 2/7, that's just a constant. There's no variable in there. All right. Now what we need to do is define an equation with those roots. So we know that the product of the roots, so a, b, c together equals 72. Except this doesn't help us. We need to define one root in terms of all the others. So I'm going to divide by BC. Okay, so now this is what we need to do, basically for the second step. Also, we'll mention if you want to see more about using product or some of the roots, check out the video in my Ultimate Desmos Guide to Digital SAT Math. There's a video that covers this topic along with some others that goes through problems in detail, but for sum of roots and product of roots. Now the last step, we have to define x1 as a list. And I always, for these problems, start with -2, 0, and 2. Let's add some more random numbers. Okay, now notice it's working out perfectly. We don't really care so much about M, B, C, or A. What we're concerned with is the value for K. And right here, once we have enough values entered in for all of our various constants, we get K equals 40, which is the correct answer. So this is how you could do this entire problem in Desmos and solve it. All right, next up, let's talk about question number 9. This one was on the Blue Book practice tests when they changed practice tests 1 through 3 last summer. They updated them. And then when they came up with the new practice tests and they retired 1 through 3, I believe they removed it or got rid of it, if I remember correctly. Anyways, you have a bunch of functions here. When you increase x by a factor of c, the function increases by 27. Which equation has 1 over c as the coefficient of x? All right, so there's two different ways you could think about this. Here's one way. You're looking for 1 over c as a coefficient of x, right? Okay, so that means if you go through each of these, in the first one, the c has to be 2. In the second one, the c has to be 6. In the third answer choice, c has to be 4. And in the last one, c has to be 3. So let's just go to Desmos and see, okay, if we increase the function by those values, does the answer increase basically by 27? And actually, I should probably word this. I should actually probably word this a little by. It doesn't increase by 27. I'll fix this in the PDF. Basically, increases by, I'll have to look at, see how it's worded on the practice test, by a factor of 27. Essentially, we're looking for it being multiplied by 27, not just adding 27. Okay, so I'll look up at the I'll look the wording from the Blue Book test and fix this again, like on the PDF file, just so the meaning is clear. All right, so if we look at the first one, 3 to the 1/2 x. All right, so here's the function. So what I'm going to look at, basically what I'm looking at is, okay, let's say I start with f of 0, and then I increase by c. So 0 plus 2 is f of 2. All right, what I'm looking at is, did the function increase by, again, a factor of 27? Meaning, if I take f of 2 and I divide it by f of 0, do I get 27 as my answer? No, I do not. Therefore, that is not the correct answer. Now we can repeat the process with answer choice B, and all I have to change here is make this to the third and make this 6. Now, actually no, sorry, I do have to change this. Now I'm comparing f of 0 to f of 6 because I'm increasing x by 6, by a factor of 6. So this becomes 6, and let's make this 6. Notice when I increase my x value by 6 from 0 to 6, the output, f of x value, has gone up by a factor of 27. That confirms this is the correct answer. The correct answer to this is letter B. And you could check C and D. I'll just do C, won't bother spending time on D. So I got 9. I'm going to make this a 4. Now I need to change this to a 4. Now I need to change this to a 4. Okay, it's 9. It's not 27. That just confirms that it's wrong. So that's one approach. Okay, here is a second or alternate approach way to think about this problem. And let me just erase this. Okay, basically, you want each of these functions to increase by a factor of 27. That means you want all these parts that I'm putting inside the brackets to increase by 27. Okay? Like the 91 is just a constant out front. We're really looking at like what is the value which causes it to increase by 27. So, essentially what you're doing is you're trying to turn that into a 27. So, like if you think about this for this first one, right? Like in order to make 27 here, you basically need 3 to the third. So it's like, what value do you need to plug in here for x in order to make this 3 to the 1 half x, or x over 2, equal to 3 to the third? Now, let me just actually change this to 27. Okay, you could actually just do this really quickly and easily in Desmos just to find all these values. So for example, I have 3, and I'm just going to use c. 3 to the 1 half c, and we want this to be equal to 27. Okay, c equals 6. And then if we look at the next one, 3 to the third. All right, I gotta I need to put a parentheses here, and then I need to raise this again to 1 over 6, and then the c, and I want to equal to 27. Okay, notice it's 6, and I'll just tell you the pattern is going to be for all of these, the value that all of them are increased by, or the x is increased by in order to increase the overall function by a factor of 27 is going to be 6. That's just how these are all set up. C, for this one for C, when I type it in, again, C is 6, and it's going to be true for D. So now you could just, so once you confirm that, then you just go through and you see which one has a factor of 1 over C, or 1 over 6, in front of the x. As a coefficient on the x, well, it's obviously letter B. So this is just an alternate way to think about it. The first approach, I took the answers and I said, what would the c value be based on this problem? 1 over c. What would the c value be? And then I checked and I saw which one was correct. An alternate approach is take each equation, find what the c value has to be, which for all of them is 6, and then just look and see, okay, which one has 1/6. So however you want to think about it, two different ways you could do this problem. Official exams, the math section. All right, the first one is this one that asked for cosine p over sine p, basically had an angle on the unit circle. And essentially what's going on here is, okay, if you draw, say our circle looks like this. All right, and we have basically O is right here at the center. So like say here's your x-axis, here is your y-axis, x and y. Okay, and so right here would be O at 0, 0. Out here at 1, 0 would be A. And then technically down here on the unit circle would be something like this. Now, what I'm going to do is, here's point B, sorry, draw the angle that we have here, angle AOB, okay, AOB. So it's this angle right in here. And they're asking for, this is the angle, in other words, that measures p radians. And they're asking for the value of cosine p over sine p. All right, now, the problem is it going to be a positive value or a negative value? So most unit circle questions, you just, we instinctively know that the cosine the cosine associated with the angle is just the x-coordinate of the point, which in this case would be 5, and then the sine of the angle is the y-coordinate associated with the point, which in this case would be -8, And that's because, you draw a right triangle, you can see that the cosine is going to be the x for the angle, and sine is going to be basically the x or the adjacent, sine is going to be the opposite or the y. Okay, the problem is, though, technically when you're doing with a unit circle, we're dealing with an angle that starts here, right, and would be going all the way around. In other words, you're talking about, in this case, a quadrant 4 angle, an angle that is between 3 pi over 2 and 2 pi radians. However, the actual angle we're dealing with is this small angle right here, which is less than pi over 2 radians, i.e. less than 90 degrees. So my initial thought on this was that the answer would be positive because the angle itself is less than 90 degrees. It's less than pi over 2 radians. And, any angle between 0 and pi over 2 radians has a positive sine, a positive cosine, positive tangent, because it's essentially equivalent to a quadrant 1 angle. However, after talking this over with one of my friends who's also a math teacher, the fact that it is labeled or named as angle AOB seems to indicate that the angle will in fact actually be a negatively drawn angle. What I mean by that is, and let me just clear out some of the stuff here. So, like tracing it out the way I did originally, AOB, it starts here and it goes down in the clockwise direction, which would make it negative. Therefore, that would make this that would make the answer negative here because the excuse me, the sign in quadrant 4 is negative, and therefore the answer would be just this negative 5/8, or you could also put as a fraction negative 0.625, or you could also put the 0 in front of it as well. But regardless of how you want to write it, because of the fact that it's named as AOB, meaning starting here and going down here, that would seem to indicate that it is drawn, again, in a negative direction like this, which would mean that, yes, it will have a negative sign value. In other words, this is a quadrant 4 angle, is really what it is telling us in terms of its cosine and its sine. That means the sine will be negative, therefore it will be, positive 5 over negative 8. So, therefore, correct answer for this one would be either one of these, and I believe it should be negative. All right, next up, question directly below it, number 2. So, for this problem, you're given an equation. It's basically, essentially, it's like the vertex form of a parabola, quadratic equation. And you're told it has no real solutions. What is the greatest value of t? So here's the thing. Basically, if you think about this, in order for this problem to have no real solutions, if you went ahead, okay, don't worry about the h here, but moved the two constant terms, the two number terms, over to the right, so it becomes 2t minus 27. Okay, in order for this to have no real solutions, basically this expression on the right must be less than 0. So if you try to go ahead and solve this, basically you divide by 8, and then you would go ahead and you square root both sides. But on the right side, if you have a number which is less than 0, then it's going to be a negative value, and you square root that, it'll give you a complex number, i.e. no real solutions. And since that is what you are looking for, this is the inequality we want to set up, basically. We want a negative on the right side for this problem. So you just set up this inequality, you go ahead and solve it. Get rid of that. Plus 27 on both sides. And then you get 2t is less than 27, divide by 2, t is less than 13.5. Of course, that's not an integer, so the largest or greatest possible value of t is just going to be 13. Now, of course, we can go to Desmos just to solve this entire thing out or verify it. And basically, Desmos, what we're going to be looking for is a vertex of this parabola. Now, first of all, for h, that technically is not going to matter. That's just the x coordinate of the vertex. That just slides it left and right wherever you put for that. So whatever, I'm just going to put 5. We're looking for the vertex of the parabola to be, since this one opens up, we're looking for it to be above the x-axis. Okay, that will give us no real solutions. So notice we have that right now, but we want to see how big can we make t in order for that to remain true. So notice I slide this all the way out to 10, it's still not there. Okay, so let's jump it up to 20. Also, because it tells you that they're integers, I can just change the step value to 1, so I don't have to scroll through all the decimals. So 11, 12, okay, 13. Notice it's still, there are still no real solutions. Do not have any x-intercept values. However, notice what happens when I jump to 14. Now I do have 2 real solutions, i.e. 2 x-intercepts, 2 zeros, 2 real zeros, so on. So this just confirms the largest integer value for t here is going to be 13. Right, next up, bottom of the page, number 9. This is actually a brand new question. This is a tricky question. And the approach that I would take is as follows. Excuse me. So, if you want to do this by hand, I will show you here is how you have to approach this. First, if you plug in 0, notice that 0, 0, 0, you're going to get basically the square root of c equal to 24. That means c has to equal 576. So now you can go ahead. First of all, I'll put the 576 at the end. Now you can plug in the 9, all right? So let me just erase this so we can see the original problem. So we've got 9 cubed plus a times 9 squared plus b times 9, okay, plus 576. The only way that I've seen to solve this is basically because you're trying to figure out what 9a plus b is equal to, is to do the following. First, factor a 9 out inside here. You get 9 squared plus 9a plus b plus 64. Okay, and again, this is also equal to 0. Now, this 9 in front, you could technically remove this. Like, you could bring this outside as a 3. But it technically doesn't matter because you divide by 3 on both sides, and 0 divided by 3, it's still 0. So this 9 that I factored out, you can technically just ignore that. That part doesn't matter. Now, here's the whole trick, or here's the whole key. Okay, this whole thing under the root has to equal 0, right? Therefore, so like I'm just going to get rid of the root and write it like this. So this whole thing equals 0. So what does 9a plus b have to equal? Well, you subtract over 64. You subtract over, this I can rewrite now as 81. So 9a plus b, I'm just, basically separating those terms on one side, is equal to negative 64 minus 81, or negative 145. And that's it. That's your answer. That's how I know. This is the only way that I know of to solve this algebraically. If you have any other suggestions or methods, again, how to do this by hand, feel free to leave them below. Now, here's how we could do the entire thing in Desmos. Excuse me. So again, because this has this radical in the problem, you have to recognize initially that, again, c is going to be 576 and type that in before you can do your regression. So here's what I mean. I'm going to type in our 2 points to a table. Then I'm going to do a regression, but it's only going to work plus ax1 squared plus bx1. It's only going to work if I replace c with what I know it's equal to, which is 576. Okay? if you don't do that, if you just leave it as c, then it gets all haywire and it doesn't give you the correct answer. See, this r squared is, is awful. It's wrong. It's not accurate. So you have to put the 576 in. Now, it's given us values for a, it's given us values for b. We have the perfect r squared value of 1. So all I have to do is type what's 9a plus b, right here, negative 145. So this is how you could do the entire problem in Desmos using regression. But again, you have to be able to recognize that when you plug in 0, the square root of c is 24, which makes c 576, and type that in. And this is just a method that's a little bit quicker, a little bit faster than the one I demonstrated in the video. So the first start of this is the same as the solution I did, which is to plug in just 0 for x. So you plug in 0, 0, 0, and then that's equal to 24. So you get, 24 is equal to the square root of c. C equals 576. So that part's the same. That's the solution that I did. Okay. Then you go ahead and you plug that in. But now what you do is you plug in, let me just erase this so we can see the original function. You plug in 9 for x. So here we have 9 cubed. Here we have a times 9 squared. Here we have b times 9. And here we have the 576. All right, and then we set that equal to 0. 9 cubed is going to be 729. 9 squared is going to be 81. 9 is just 9. And then we have 576. Okay, and again, that's equal to 0. Next, what I'm going to do is 729 plus 576. Just combine those, and you can add them together in Desmos. So it's going to be 1305. So now we have this expression, and we can just square both sides. And we get 1305 plus 81a plus 9b equals 0. Now, if we subtract the 1305 over, move it to the right, so it becomes negative, you can just basically factor a 9 out here, and then you're left with 9a plus b, and then just divide by 9. Oops, divide by positive 9, not negative 9. And therefore you get 9a plus b equals negative 145, which is the correct answer. It's just, you can see here, it's a little bit quicker, a little bit easier, and fewer steps, a little bit maybe more intuitive than the method that I showed in the original video. All right, top of the next page, question number 10. This is a monster of a problem. I'm not going to lie. So basically, you have two quadratics here, and each quadratic obviously has these each have two solutions. One is larger than the other. Then you take the solutions, you end up adding them together, and those two new numbers, two new values that you get are solutions to a different quadratic, and that different quadratic that you get has a constant in it, and they want to know what the value that is. Okay. So first, I will show the method by hand, then I'll show you how you could do it using Desmos. Because it's such a long problem, I'm probably going to skip some steps and try to just go through it as quickly as possible. So, okay, first thing here, if you want to, actually, we could just, I'm going to complete the square. Rather than quadratic formula, I'm just going to show you completing the square. So, b value is 10, half of 10 is 5, 5 squared is 25. So I'm going to add 25 on both sides, and then this gets factored as x plus 5 squared equals 5. Square root both sides, plus or minus root 5. X equals negative 5 plus or minus root 5, okay? Those are the two answers to the first equation. R is less than S. That means that R is the negative 5 minus root 5, and S is the negative 5 plus square root 5. Okay, now let's repeat the second thing, well, the second equation. So it's going to be x squared plus 10x plus blank. We already know it's going to be 25, negative 5 plus 25 x plus 5 squared equals, this one is 20. It's going to be x plus 5 equals plus or minus root 20. X equals negative 5 plus or minus, and the square root of 20 I will simplify to 2 root 5, because it's 4 times 5 and the square root of 4 is just 2. Alright, so now let's just see which, okay, t is the smaller, so that's negative 5 minus 2 root 5. U is negative 5 plus 2 root 5, the larger. Okay, now we have to find the values of, let me just see here, r plus u and s plus t. Okay, so r plus u. Negative 5 plus negative 5, negative 10. Negative root 5 plus 2 root 5 plus root 5. All right, not that bad. S plus t. Negative 5 plus negative 5, negative 10. Positive root 5 plus negative 2 root 5, negative root 5. Okay, I got a nice pair of, like essentially kind of like say the conjugates, even though these aren't complex numbers, but So these are my two solutions to my new problem. All right. So now the way that I actually go through and set up the new problem is basically as follows to solve for c. Let me just slide over here. So if I go through, again, completing the square, minus c plus blank, 20 divided by 2 is 10. 10 squared is 100. So I'm going to add 100 here, add 100 here. This becomes x plus 10 squared. Over here we get 100 minus c. Okay? Now, notice you square root both sides. X plus 10 equals square root plus or minus 100 minus c. X equals negative 10 plus or minus 100 minus c. All right. So notice this is what you get if you do completing the square on this equation, and my answer choices should be of the form negative 10 plus or minus square root 5. So now, matching up the corresponding parts, this equals this. 100 minus c equals 5. Negative c equals negative 95. Divide by negative 1. C equals 95. That is the correct answer. This is a ridiculous amount of work. This would obviously take, 2 minutes, 3 minutes, probably even longer than that on a test, writing this whole thing out. But the correct answer, which I'll just put over here, slide over here, is 95. Now, here's how you can do some of the work. Here's how you can do it in Desmos. It's still going to be a fair amount of work, but just, whatever. I'll go through the process and show you. So I'm going to take the first equation, going to do regression, and I get one answer here, and then I'm going to copy this. But what I'm going to do is I'm going to set, I want x1 to be less than that. Okay, so I have my two answers here, right? I can't carry these answers over. Even if I used R and S in these equations, I could not carry them over to do another regression statement later. So I'm just going to have to estimate them, and you'll see it's actually going to work out fine. All right, R is less than S. So R is the smaller number, which is the negative 7.23607. So we can define that. First of all, get rid of that graph. Then the other one is S, which is negative 2.6393. Okay. Let's move on to the second equation now. All right, so let's see. I think the other one's going to be less than this. Actually, no. What am I doing? First, sorry, I want to copy this. There we go. Second one is the one here where I want to make it less than that. Okay, perfect. So here are my two answers for the second equation for t and u. Okay, t is the smaller one, so that means t is equal to the negative 9.4 47214. S is the larger one. Not S. U is the larger one. U is, I'm just going to slide this up just for a second so I can copy it down. Negative 0.527864. All right. Now, I got to do R plus U and S plus T. R plus U, S plus T. All right, so I have these two values, right? These are these are the two solutions to the new equation. So I'm going to call this A, and I'm going to call this B. And then what we're going to do is we're going to go to Desmos and we're going to do a regression where I'm going to say, okay, x squared plus 20x plus c, the original form, the equation I'm looking to solve, that is going to be regressed with x1 minus a and x1 minus b. Let me just clear, there we go, some of this stuff out. All right, now, basically what I'm doing here is I'm taking the original standard form version of it, and I'm just regressing it to its intercept form or to its factored form, because I know the factors or the solutions basically are like, r plus u and s plus t, so the factors are going to be x minus parentheses r plus u and x minus parentheses s plus t. Now, you can already see here it's 95.0004. Technically, though, I do need to define x1 as a list. Now, I don't know why the residual doesn't, oh, I know why. The residual doesn't work out exactly even. It doesn't give you exactly 95 because I had to estimate up here for R and S and T and U. Because I don't have the full exact decimal value, that's why it doesn't work out to exactly 95. But the thing is, even if you had to round it off here, it's 95.00. That's the same as 95. You're still getting the same correct answer. So in any case, this is how you could do it in Desmos. As you can see, it's still a fair amount of work, but you can do it a little bit quicker. And last, I want to look at question number 10. So for this problem, this on the video, going through the explanations took a significant amount of time. Okay, basically, like it was a ton of work figuring out all the different answers and adding everything together, and even using Desmos in it, it was still rather lengthy and other time consuming. However, there is a Desmos solution here that is so much quicker and so much faster and easier that I'm going to show you now, thanks to one of the frequent commenters on my channel. All right, so here is basically the idea. I'm just going to make a little chart here, just so this will... Okay, so we have the first equation, which is the x squared plus 10x plus 20. We have the second equation, which is the x squared plus 10x plus 5. And then we have the third one, which is the x squared plus 20x plus c. Okay. Because what I'm going to type in Desmos is a gigantic long regression statement with R and S and U and T and everything, but I just want to show you where all the various numbers are coming from. Okay, so remember, sum of roots is going to be negative b over a. Product of roots, c over a. Okay, so for the first equation, the sum of the two roots is just going to be negative 10. It's really negative 10 over 1, but we can just make it negative 10. For the second equation, sum of the roots is also going to be negative 10. All right, third equation, sum of the roots is going to be negative 20. Okay, again, negative b over a, b is 20, opposite of that, negative 20, a is just 1. All right, now, product of the roots. First equation, c over a, 20 over 1, which is 20. Second one, c over a, 5 over 1, which is 5. Third one, it's just c over 1, or just c. So now what we do is we go to Desmos and we set up a system. It's really a system of equations with like 6 different equations that we're plugging in. So let me just slide this over. Okay, so here's what we have. we know that the sum of the roots, which is r plus s, for the first equation, and I'm actually going to I'm going to build this out, putting in the first, each corresponding thing at the same time. Okay, we know the sum of the roots for the first equation is negative 10. Then we know the product of the roots, which would just be r times s, okay, is equal to 20. Then we go down to the next one. We know that the sum of the two roots, which is t plus u, is equal to negative 10. And we know that the product of the two roots, t times u, is equal to 5. Okay, so all I'm doing is I'm filling in the sum of the roots from the first one, what number it's equal to from the chart. Product of the roots from the first one, number it's equal to from the chart. Do the same for the second equation. Third equation, same thing. Here's where you have to be careful, because basically the sum of the roots is going to be the r plus u, that's root 1, plus s plus t. So it's all four things, and we know that they are equal to negative 20. And then now the product of the roots, here's where you have to be careful. It's r plus u and s plus t. Okay, so root 1 is r plus u, root 2 is s plus t, and they're multiplied, so we have to put them in parentheses, and we know that they're equal to c. All right, so now, if you notice, once I type this whole thing in, it gives me all the values, and these are the correct values. Except that we do need to put in, technically we need to put in it gives us the correct value of c is 95, but we should put in the qualifiers of the fact that r is less than s, okay, which it's already true. It's already giving me the r value is negative 7.23, which is less than the s value of negative 2.76, so I actually didn't need to do that. It met that condition automatically. Now, the t is less than u thing is actually not true, because if you look here, u is the smaller value. So if I put this in, then it'll just flip them. But in terms of finding c, it actually doesn't matter. Whether r is less than s or t is less than u. That part is actually irrelevant. So notice you can put these constraints in at the end. I have c is 95. This is the entire thing typed out in Desmos. It's really a system of like 6 different equations that it solves, and it gives you the correct answer in so much less time than all the manual work that I went through solving this the first time. Take a look at the top of the next page. Problem number 4, sum of solutions problem, and you have a constant. I'll show you first how to do this by hand, then we'll take a look at the Desmos solution. So the way to solve this by hand is basically to do the following. Bring everything over to one side. So I'm going to move everything over to the left. So in other words, I get t minus 81 squared minus 3t times t minus 81 plus k times t minus 81. So everything's equal to 0. Then what I'm going to do is I'm going to factor out a common factor of t minus 81. That's going to leave me with t minus 81, because it's squared initially, so there's still one left. And then this cancels out, minus 3t. This cancels out, plus k. All right, so now, basically, we have 2 solutions. Solution number 1 is just t equals 81 from this first parentheses. Solution number 2 comes from this gigantic second parentheses, or what's in the entire expression inside the bracket. So we know that the sum of solutions is 83. So 81 plus 2 equals 83. That means this entire solution inside the bracket right here, okay, this entire thing must be equal to 2. So we can go ahead and we can basically do the following. Let's first make it negative 2t minus 81 plus k. All right. So now, actually, sorry, we're going to use that 2 in a second. What we're going to do is we're going to first, solve this for t, and then in terms of k, and then after we do that is where the 2 will come into play. So we get negative 2t equals, I'm going to add 81 to the right, I'm going to subtract k. Then I'm going to divide by negative 2. So t is equal to, now I'm going to flip the signs here. So this is negative and negative. I'm going to put this first because it becomes positive, and I'm going to put this second. So k minus 81 over 2. So solution number 1 is this. Solution number 2 is this. Together, they add up to 83. Like I said, that means the second solution, this one right here, has to equal 2, because 81 plus 2 equals 83. Therefore, you can now say k minus 81 over 2 equals 2. Solve this for k. 2 times 2 is 4. Add 81 to both sides. K equals 85. Again, that's the approach to do this by hand. What I did is I got everything equal to 0. I factored out a t minus 81 common factor. I then solved for the two solutions, one of which was 81, the other of which is this expression that has a k in it. And then I used the fact that the sum of the solutions is 83 to determine that this second solution had to equal to number 2. And I solved for the value of k based on that fact. All right, let's see how you could do this in Desmos. All right, so basically what we need to do here is I need to, again, pull everything over to one side. Really the same first step that I did solving it by hand. Okay, then I'm going to do regression, and I'm going to regress this to its factored or intercept form. So I'm just going to do, basically, since this is a quadratic, I know it's going to have two roots or two solutions. I'm going to just call them a and b. Okay? And then also I know that my two roots or my two solutions, the sum of them is equal to 83. However, what you have to do is you have to get this equation in terms of one variable or one constant alone. So I need it to be a equals 83 minus b, or you could also do b equals 83 minus a. If you want to know more about how to solve a sum of solutions problem using this method, check out my ultimate Desmos guide to digital SAT math. Is in, I believe, part 9, and I go through and explain how to do it and look at some example problems. All right, so now we can just define t as a list. All right, and it should be giving us a value for k, but it's not giving us a value for k. Why is the regression not working? Oh, I put an x1 here. It's supposed to be t, not x1. That's the whole reason for the error. There we go. Sorry, everything's supposed to be in terms of t. I mean, you could do it in terms of x1, but I'm just doing t to keep it consistent with the problem. All right, so once I enter my list for t, there is the value for k. It is 85. Okay, and basically that's it. That's all you have to do in Desmos to solve this problem, and we can move on to the next one. 25, worksheet number 1 that I'm currently on. And now I'm looking at problem number 4. Okay, so this one, the trick or the quick or easy way to solve this is to first of all recognize that 81 will be a solution for t. Because if you plug in 81, you get 0, 0, and 0. Okay, in other words, you get 0 equals 0, which is a true statement. Thus, the two solutions for t will technically be 81 and then 2. The fact that the other one has to be 2 comes from what it tells you in the problem, which is the sum of the solutions is equal to 83. Okay? So I'm going to set t equal to 81 and 2. I'll come back to that in a second. Now I just type in the original equation as a regression statement. And notice it now gives me the value for k, which is 85. So this is a super fast, quick, easy way to solve this. But again, you do have to recognize that 81 is going to be a solution, and then as a result of that, the other solution is going to be 2. Thank you to the user on the channel that suggested this. The name will be at the bottom of the video. I just don't have it in front of me right now as I'm going through my notes and looking at this. All right, let's look at question number 5 here. So this is actually a repeat question. This is one that has come up before. Basically, you have this expression, fourth degree polynomial. It can be factored 2 different ways, and like one set of the factors are positive or integers, the other set are non-integers, and then you want to add together, the values of A and C. So there's 2 different ways to show this. I like to do this basically entirely in Desmos. I don't really know of an easy way to do this by hand. I mean, the integer one is easy. It's going to be 3x squared and 2x squared, and you could go through, the factors of 55, and basically it's going to be 11 and 5. It's going to work out like this because this is 22 and this is 15. They add up to 37. Okay, so basically A is 11, C is 5. That's easy. The non-integer part is what's, difficult. So there's 2 approaches you can take in Desmos. I will show first the method, I guess the method that I actually prefer, and then I'll show you what might be a quicker or easier method using regression after that. So the way I like to think about this is, okay, you think about factoring, right? You do FOIL. So the outer and the inner, these things together will, you multiply them out, add up the 2 terms, and you're looking to get 37. So like, 2a plus 3b equals 37. And then also you need the 2 terms here, like the a times b, to equal 55. The last 2 terms multiplied equal 55. So you set up a system of equations using that, except I'm going to use x and y. And then you just look for the solutions. Those are going to be your a and your b and your c and your d. Okay, so here's the graph. Maybe just zoom in a little bit. So here's one solution, here's one solution. Let's just export these. Okay, so we have the 11 and the 5. That's the A. And by the way, and I wrote that as C. That's wrong. That's a B, not C. Sorry, this should be B here, A and B. And then C and D are the other 2 intersection points. The 7.5 and the 7 and 1/3. 7.5 and the 7.333, repeating, which is basically just going to be, 22 over 7. Okay, so A plus C, 11 plus 7.5, 18.5. That's your correct answer. That's what you would type in. That's what you would report. You could also technically do it as 37 over 2 as well. So either 18 over 5 or 37 over 2, either of those would be accepted as correct. So that's one method to do it. Now I'll show a second alternate method you can use. So you can do regression. The problem is you have to do a little trick. So, okay, we're going to do the original statement. Okay, then we're going to regress to 3x1 squared plus a, 2x1 squared plus b. Okay, and then we'll define x1 as our list. Let's see if the random function will work here. Yes, we get a is 11, b is 5. Okay, so now what you do is you basically, you do the regression again, but you change the order of the parentheses. You still keep it as x1, but you put the 2x1 plus, in this case, d first. What's going on here? And then the 3x1 plus c would be second. Get rid of all this. Okay, so notice here, I do the regression again, but I flipped the order of the parentheses. That causes it to find the second solution, basically the non-integer solution. Right here, see it's 7 1/3, blah, blah. So now, what's the value of a plus c? A plus c, 18.5, there's your answer. So this is the way you could do it. I don't know why flipping the order of the parentheses, but keeping the same, keeping it as x1 and everything causes it to find the second solution, but it does. And this is an alternate way you could do it. Um, Third way you could do it as well, following the same approach, is you could take the original thing here. You could get your first answer. So let's just say, whatever, 11. Just write that down. And then you could put in a qualifier or constraint basically. So like let's make a less than 10. See if you do that, that'll force it to get the second answer, and then here you'd have to remember technically that a is really the c value, so you could then get the 7.5 to add to it. So that's an alternate way if you don't want to like copy or retype the whole thing. You can put in a constraint, but you technically wouldn't know which way to go to make a like less than the 11 that it originally found or greater than it. So you might have to do some testing on that to see. Next up, here we have a right triangular pyramid. This is a repeat question. This one appeared previously. Again, don't remember the exact month, but it was in 2024. So if you think about pyramid, okay, it looks, this is maybe a bad drawing. See if I can get this a little bit better. Okay, there we go. Each edge is 52. Okay, you can see there's 6 total edges. So the total surface area is whatever, some number, root 3. So what's the value of k? All right, so if you just take one face here of an equilateral triangle, 52, 52, 52, you want to find its area, you can split it up. And we know since it's equilateral, this is 60, this is 60. This 60 at the top is split into 30 and 30. So now what happens is, let's get rid of this. This becomes 26 because if you think about special right triangles, 30, 60, 90, the relationship or the ratio between the short leg side across from the 30 down here and the hypotenuse is basically 2 to 1 or 1 to 2 depending on which way you're going. So you divide the hypotenuse by 2 to get this, and then the height is going to be 26 root 3. You multiply the short leg by the square root of 3. So the area of one of these is going to be 1/2 times the base, which is 52, times the height, 26 root 3. So this just becomes 26. Therefore, the whole thing becomes, just make sure I get this correct, should be 676 root 3. So again, that's the area of one of the triangular faces, and there are 4 of them. So you're going to multiply this by 4, and that gives you 2704 root 3. Therefore, k is just going to equal 2704. So that's your answer. Now, you could save some time on this if you know the shortcut formula for the area of an equilateral triangle, which is just s squared root 3 over 4. You could just take 52, square it, root 3 times 4. But now there's 4 faces, so when you multiply by 4, these are just going to cancel out. So notice it's just really 52 squared root 3. And let's see, that should give us the 2704. Get rid of that. That we got using the other approach. Let's just confirm. Yeah, 52 squared, 2704. So that's just an alternate way to think about this. Probably, potentially save a little time if you know the shortcut formula for area of an equilateral triangle. All right, next up, this is another old question that's appeared on a number of previous official exams, and there is a shortcut you can use to solve this. I will show it at the end. First, I'll show the theoretical way to solve it, then I will show how to do it in Desmos, then I'll give you the shortcut at the very end. Okay, so if you're going to solve this by hand, what you would do is you would square both sides. On the left side, you get k minus x. On the right side, just to save some time, it's going to be 3136 minus 112x plus x squared. Basically, you write 56 minus x twice, and then you FOIL it out. Okay, now we get everything equal to 0. You get x squared minus 111x, another one there, plus 3136, and then we got to move the k over, minus k. Again, I just added x here, and I subtracted k. Move those over. Now you can basically set up the discriminant, b squared minus 4ac. And when you want exactly one real solution, you would set that equal to 0. So we're going to have negative 111 squared minus 4 times 1 times 3136 minus k, and we set that equal to 0. I'm not going to bother solving this by hand because I can just go to Desmos and I can just type in a regression statement to get the answer. 6 minus k tilde 0. Okay, so that's the value of k, but notice the question doesn't want k. Just scroll back up here. The question wants the value of 4k. So what is 4k equal to? 4k is equal to 223. Okay, so the correct answer to this problem, what you would type in is 223. Now, let's see how you could solve this on Desmos. So all we're going to do is, the general approach is basically we're still going to square both sides to turn it into a quadratic, and then we're going to basically get it equal to 0. So, okay, the root k minus x squared just becomes k minus x. And then for the other thing, for the other expression, the 56 minus x quantity squared, I'm not going to actually square it out. I'm just going to leave it, like that. You don't have to bother squaring it out is the point. Then I'm going to do regression, and I am going to send this into its vertex form, because this is a quadratic now, but the y-coordinate is going to be 0. So instead of having a plus k at the end here, I'm just going to put nothing because I want 0. I want it to basically be 0 because that would mean that the vertex is on the x-axis, which means there's only one real solution. If you want more info about how this works, check out part 10 of my Ultimate Desmos Guide to Digital SAT Math. I go through this specific type of operation in detail and work through several problems showing you how to do it. Okay, so now we just need to define our list for x1. Okay, so once I've typed numbers in there, a couple of numbers in there, notice it gives me the k value that I had previously. And again, I don't want k, I want 4k. So what is 4k? Now the thing that's unusual is sometimes with these regressions, like notice here, something's wrong where it's not coming out to 223, which is the value you want. So on all of these problems, the value, like this minimum value of 4k or whatever, it's going to be an integer. Because when you solve it using the technique I showed initially, using the discriminant, it comes out to an integer. You're not going to have a decimal like this. I don't know why it's doing it here. There. It looks like if I add another value, then it's able to, like, I don't know, get rid of the decimal things. And see here, it even keeps it even when I delete them. So I don't know. If you have an issue where it's coming out with a decimal like that, just add another value or two to the list and see if that will fix it. But in any case, the answer is 223. This is how you could do it entirely in Desmos. Now, here's a third approach. Again, here is a shortcut just like the last problem. The 4k value for this specific setup, this type of problem, will always work out to be 4n minus 1. And when I talk about n here, I'm talking about this number that is either like the number minus x or x minus a number. Whatever the number you see in the problem is, the 4k value is always 4 times that minus 1. It always works out like that. 223. There it is. So you can just memorize that. I went through in one of my videos, basically an alternate solution video, I went through and worked out algebraically to show why that happens, like basically solving the discriminant, but with, with n in it instead of an actual number for it. But that's the shortcut approach. It's always going to work out like that. Okay, let's look at this next problem, number 5. This is a percentage problem. So basically, what's happening here is you have something, you have this amount of money earned in 2016. Okay, then in 2017, it went up by 11%. Then in 2018, it went up by another 3%. The way this is worded, I think, is a little confusing or difficult for some people. Basically, what it's saying here, this earned in 2016, y times so much earned, basically what it's saying is you take the 2016 earnings down here, you multiply this by, sorry, the amount you earned here is equal to the 2018 earnings multiplied by y. You're multiplying the y by the 2018 earnings, not by the 2016. You're multiplying it by the 2018 earnings to get the 2016 earnings. That's how it's supposed to be set up. That's, I think, what they're asking for in the problem. So essentially, really what you're doing here is you're taking 2016, you increase that by 11%. That's the same as multiplying by 1.11. It's really 1 plus 0.11, which I just made to 1.11. Then you take, this whole amount, which is the 2017 amount, and you increase it by 3%. That's the same as multiplying by 1.03. Once you do that, you get the 2018 earnings. Okay? So now you go ahead and to solve this for 2016, you're just going to divide both sides by 1.11 times 1.03. So in other words, 2016 is equal to 1 over 1.11 times 1.03. And this entire thing, this is the y value. This is the number they're asking for in the problem. So basically, it's going to be letter C. It's right here, 0.87466, blah, blah, blah. Correct answer is letter C. I mean, you could take numbers here, and you could actually, like, if you wanted to, you could work it out with numbers. So just to go to Desmos and show you. Starts off at 100. Okay, after 2017, it's that. Then after 2018, it becomes this. So now you're basically saying, okay, 2016, I'll call that, my x1, is what value, actually here, sorry, 2016 was 100, that's what I started at, is y times my 2018 number. Actually, I don't want to use y, because let me just pick whatever random letter, b. So 2016, which I started with $100, let's say, is b times, and then this whole expression represents the 2018 earnings. And you can see here for b, I get the 0.8747 if it's rounded, or 0.4661. Same number I got by doing it using this method. So if you want to use actual numbers to think about it that way, that's fine too. It's basically the strategy of picking numbers, but the correct answer for this one should be C. So this first one, this is one of the trickier questions that I saw being reported. And basically what was going on is supposedly you were given a graph with a bunch of points, resembling a quadratic function. And it gave you an equation, which it said was basically, the model for that series of points. So I've, tried to reproduce that on this graph here that you see on the screen. All right, then, but the graph had one kind of outlier point way up here on the y-axis, clearly not in line with all the other points. And then it said, okay, you make a new function by basically using the same set of points, but you remove the outlier point up here. And, what is true about the a and c values of the new function? In other words, what happens to the coefficients of the x squared term and then just the number term at the end when you do that? So I will tell you, and then the two options here were obviously a is going to increase. I mean, it says greater than 0.07, but really it's just a is going to increase when you do that, and c is going to decrease. C less than the given value of 6.07. All right, so I'll tell you the answer is C. At least that's what I believe. It's both. Both of these will be true for the new function after you take out the outlier. And the reason, first I'll kind of explain the theory behind it, and then I will show you a specific example in Desmos just to confirm this. So the reason that both are going to be true, let's start with C. Okay, so if you take away this outlier point up here for C, and even if you don't add in the actual, where the actual point on the true quadratic, model would be, say like down here, even if you don't do that, now if you go through, okay, and you want to draw like the best fit line through all of these points, let me just pick a different color here. Sorry, not best fit line, best fit curve, essentially. Notice what's going to happen is it's going to be pulled down. Essentially, now the best fit curve is going through all of these points which are on the same model, so it's going to look, something like this. So C, which is really the y-intercept value, where it crosses the y-axis, is going to go down. It's going to decrease. Okay, so number 2 is going to be true for sure. Like that should be obvious that this outlier value way up here is pulling, ends up pulling up the y-intercept from where it otherwise would be. Okay, now the question is, what happens to A? So it's not easy to see. It's not apparent from my just rough sketch or estimate here. But basically what's happening is when you add this outlier point, that's shifting the graph up. It's basically pulling the graph up from where it otherwise would be. It's going from the green to the blue. When it does that, it forces the graph to widen in order to hit the points. Like if you put an extreme outlier, right, and you put it like way up here, it would force it, to widen a lot more, and it would be a lot more obvious to see as compared to what I have on the screen here. Therefore, if you get rid of the outlier point, it is going to narrow. Basically, as it drops down, then to hit these points, it's actually going to be narrower than it would be up than it was on looking at the blue curve here. Since it's going to be narrower, that means the A value is going to be larger or increase, so that will be true as well. So I believe the correct answer to this one should be letter C, that both are true. Now, here is an example in Desmos just to demonstrate this. All right, so what I've done here is I've basically done out 2 tables of values and 2 graphs. Okay, for the first one, which is what you see on the screen here, I put in a bunch of points. Okay, all of these points are on the quadratic function x squared plus 1, except for this 0, 6, this outlier point right here, right? Everything else you can see is like pretty much in line, everything else is in line with that function. I chose, again, x squared plus 1. So now I did a quadratic regression, and here's what I got. All right, so notice the A value is 0.965, the C value is 1.874. So now what I'm going to do is I have a second set of points and a second regression. So I'm just going to turn those on. So notice the points are basically all the same, except for basically notice so see all the red points are all the same. It's just there's the one green point that's not included. And now when I turn on, the regression, so notice what happens. First of all, you should clearly see on the graph that the C value goes down, it decreases, right? Here it is in the initial 1.87, here it is down at 1, okay? So removing that point, removing the 0, 6 point, the outlier point, causes the C value to decrease. So number 2 is clearly true. Now, what happens to A? So originally with the outlier, it's 0.965, blah, blah, blah. Now, without the outlier, it's 1. So the new A value is larger than the old A value. I mean, it's not necessarily that easy to see from the graph because the numbers are still pretty close. You're talking about a 1 versus 0.965. but the a value has increased as well. So this is just basically visual confirmation that when you take a series of points and you have one outlier value, okay, and we take the a and c values for that model, and then we take away the outlier value, then you can easily see that the c value will decrease, will go down. It'll be, so for another words, for the new function, which the red is basically the new function. So now you can see that for the g of x, which is the new function, which is the the red points here, the red curve, that both c has decreased and the a value has increased. And I will include a link to this specific graph on Desmos so that you can go look at this and access this, on your own as well, and just check out the points and confirm the points. Let's look at the last question here, number 10. This, again, appeared to be a brand new question, not a repeat. You're given this equation with x and some n's, and you're told to find the value of x to the n. So what I would do is, you're going to solve this by hand. The approach or the method I would take is basically, this 2n root means that the entire expression on the right side is raised to the 1 over 2n power. So the way you would cancel it out, you would raise both sides to the 2n power. You had x to the 2n equals, and then this and this cancel, 2x to the n plus 35. And then move your terms over. Now you basically have what looks like a quadratic type function, right? Because you can factor this. It's going to be x to the n, factors of negative 35 that add up to negative 2. Well, it's negative 7 and plus 5. Therefore, x to the n equals 7, x to the n equals negative 5. This is the only correct answer, and the reason is, I believe, because of the requirement that n is a positive integer constant. You're going to run into issues with the original problem here where you have the root with if you let x to the n be equal to negative 5. So I believe the correct answer for this one should only be 7. It should not be negative 5. However, let's see how you could solve this in Desmos. So go ahead, bring up Desmos here, and basically I'm just going to type in the given equation, except do it as a regression statement. Type nth root to get a blank root where I can put the 2n in there. Use x1 for every x, of course. Okay, now what I'm going to do is I'm going to set a value for n. Okay, notice here when I set n equals 1, it goes to 7. I'm also going to start it at 1 because we're only looking for positive integers, and I'm going to set the step to 1 so that way when I move the slider, it is only going between integer values. So notice, if I start with the 1, I happen to have the 7 answer I was getting. However, you move here, the values change for x1, right? But remember, we're looking for the value of x to the n, or in this case, x1 to the n. So if you notice what happens, even as I move the n value, x1 to the n remains unchanged. It's still 7, even as I go from 1 all the way up to 10. So this is just confirmation that 7 is the correct answer. This is how you could solve this problem. Again, completely in Desmos. You can see it's very quick. It's basically just typing in the equation as a regression statement, adding a slider for n, and then just moving it to confirm that yes, x1 or x to the n will equal 7. Worksheet number 4, problem number 10. It's this equation here with one side being equal to the 2n root of an expression and so on. So one just little trick that you could do here is after, you do have to still know or recognize that you have to raise both sides to the 2n power. You get x to the 2n equals, and then this thing just cancels out. So it's 2x to the n plus 35, right? Essentially, now you could just, it says what's the value of x to the n? You could just do, it's a trick that you usually see in calculus, like a u substitution, and you could replace x to the n just with, say, y, or just even with basic x, and then you could graph it out. In other words, this would turn into like y squared, equals 2y plus 35, or y squared minus 2y minus 35 equals 0. And then you just go to Desmos and you just solve this. And you basically just see your two answers here, -5 or +7, okay? And so it's got to be the +7 one because n here is a positive integer constant. So therefore, y equals 7, but again, y is just equal to x to the n, therefore it is equal to 7. So this was just a little trick you could use, perhaps to make it easier for solving, the final couple steps of the problem. Let's go ahead and get started here. We have the problem with the steel pipe. And so basically, what's going on here, I'm going to try to draw a picture as best I can. I don't think I can draw 3D pictures in OneNote. So basically, you have this pipe, okay, and I'm going to exaggerate it just to make sure we understand what's going on. You have this steel pipe, and basically, this technically down here you wouldn't be able to see. Again, you wouldn't really technically be able to see that opening either. But the diameter, so total distance from side to side, from the outside, okay, is 60 inches. The height is 130 inches. And then basically, just like a pipe, it's hollowed out. There's nothing in the middle. So the pipe has a certain thickness, and that thickness, basically from here to here, or I mean, whatever direction you're looking, same thing here to here, or on the other side, 5/8 of an inch. Okay. The question is asking for what is the volume of the steel pipe itself. So in other words, it's like if you filled in, just this area and then extended it all the way down, what would that volume be? And of course, the whole inside here, I mean, you can't see it because it's inside of the pipe, but the whole inside here, would be essentially hollowed out. All right. So basically, what we have to do is find the volume of the outer cylinder, then find the volume of the inner cylinder. Inner cylinder is basically the hollowed out part here, right? Outer cylinder is this outside part. And then just subtract those two. And that's going to give us the volume of basically the thickness of the pipe, or think of it as like the donut, so to speak, in the picture here. All right, so of course, we know that the volume for cylinder, the general formula is just pi r squared h. Now, you do have to be careful because you're given the diameter, which is 60. That's all the way across, which means the radius of the larger one. So I'm going to do everything. So here for the outer, the radius of that is going to be 30. We do not use the 60 because 60 is the diameter. We want half that. So we know the radius is 30. We know the height is 130. And so now we can just plug everything in. Pi times 30 squared times 130. So let me just look at my notes here. It should be 117,000. I mean, I'll go to Desmos just to confirm these various calculations. But sorry, 117,000. I forgot the pi technically. But when we go to get the answer, they're only looking for the number in front, or the constant in front of the pi. So the 117,000 is really what we're concerned with. Okay, so now let's just confirm this. In Desmos, 30 squared times 130. Okay, yep, 117,000. All right, so for now, we can find the volume of the inner cylinder. You do have to find the radius first, though. Height's still going to be the same at 130. So here's the thing. The radius here is basically going to be 30, the radius of the outer, minus 5/8, which is the thickness of the pipe. So 30 minus 5/8 is going to be the radius of the inner cylinder. So you can make that into, you can like I mean, put that in decimals however you want. You can think of it as like 29 and 3/8, or you could do the decimal form, 29.375. So whatever, we'll just do that. And then you can plug that into the formula. Now, of course, this is not going to be a nice integer, but that's fine because you just have to round the answer at the end. So now we've got 29.375 squared times the 130. Okay, so it's 112,175.175. What was it? 78125. Okay. Of course, on the test, you wouldn't necessarily need to write all this down because you're just doing all the calculations in decimals. All right, so now we can go ahead and subtract those two numbers, and that is going to give us basically the volume for the thickness, essentially, of the pipe itself. So now we can just go to Desmos. I'll just call this one, set this one equal to O for outer, so I don't have to retype it. I'll set this one equal to capital I for inner, outer minus inner. All right, so we get, and again, we're ignoring the pi here, right? So we get 4824.21875. We want to round this to the nearest whole number, therefore it just gets rounded to 4824. So it's 4824 pi, but again, n is the number here in front of the pi, so 4824 is what you would report as your answer. Question number 5. Here we have a trig problem. So you have this equation. You're told p is a constant greater than 98. Find the value of p. All right, so first I'll go through the theoretical approach to it, and then I will show you just how you could back solve it, basically in Desmos. So if you're familiar with the unit circle or like basic trig values, you would know that the sine of pi over 4 is equal to positive root 2 over 2. That means this expression inside here has to equal pi over 4. So if we set them equal, pi's can be canceled out. Just divide by pi on both sides. And then, so now you have a 1 here. You can cross multiply, and you just get p equals 49 times 4, or 196. Correct answer is letter C. But here's how you could just do it in Desmos. So what I would do is I would type, first I would type square root of 2 divided by 2, just in case you're not familiar with that decimal. Then I would type the sine of 49 pi divided by p. I would add a slider for p, and I would just go through the various answer choices. So first, I would plug in 98. Okay, do the two numbers I see in rows 1 and 2 equal? And the answer is no. So then I would go to 147. Do they equal? No. Then I would go to answer choice C. Do they equal? Yes. So that's the correct answer. And then if you check the last one, you'll see they do not equal, just confirming that it is letter C, which is correct. I have a quadratic. This, again, very, very similar concept that we've seen before. You have a quadratic equation with a constant. You're given the solution. The solution actually had another constant in it, but it didn't, that really doesn't affect anything. So if you're going to solve this by hand, what you would do is you would multiply out the left side and subtract the right side over. And then you would do quadratic formula, which would be negative b, plus or minus square root b squared minus 4 times a times c, which in this case is technically negative c, over 2 times 1. And then you get 8 over 2 plus or minus, and inside here becomes 64 plus 4c. Okay, now if you're trying to match this, notice that this is technically over a 1. So really, there's multiple ways you could look at this. The way that I did it is I basically said, okay, how can I get rid of this 2 on the bottom? Well, it can divide into the 8, but we also need something out front here for it to cancel out with as well. So you factor out a 4 from the 64 plus 4c inside the square root, and then that 4 will go outside as a 2. So then what you would be left with is, you have a 2 here, you have 16 plus c, cancel, cancel, cancel. So now we have 4 plus or minus root 16 plus c. And this is basically equal to k plus 9 root 2. Okay, so first of all, k equals 4. That doesn't really matter for our purposes, but now essentially what you're doing is you're equating these two square roots right here. So the way I would do that is I would bring the 9 back inside, and technically it goes inside as a 9 squared. So that means you have, basically just for the part under the radical, 16 plus c equals 2 times 81, or 162. Therefore, c would equal 146, and that would be your final answer. Now, here's how you could solve this entirely in Desmos. So what I'm going to do is I'm going to type the first equation just as a function, which means I am going to subtract over the c. Okay, now what I'm going to do is I'm going to note that when I evaluate this given solution in the function, since it is a solution, the expected output is 0. Now, here's the problem. If you notice, if I plug this in, right, it's giving me k equals 1 and c equals some random number. It's not giving me 146. This is not correct. This is not what we're looking for. What you have to do, and the reason it's happening is because there are two constants here. There's a c and a k. What you have to do, or what you have to recognize, is that if one solution is k plus 9 root 2, the other solution will be k minus 9 root 2. Therefore, you have to go into Desmos, and you technically have to set up it's like a system of equations where you have both of the solutions, and you are doing regression with both of and setting both of them equal to 0. Then it works properly. It finds the value of c is 146. It finds k is 4, and we get our correct answer. Okay, so just keep in mind on a problem like this, where technically the reason I have to do this is because I have two constants. So it technically needs like two constraints or two things to check against in order to work. 5. The first question up is problem number 9. It's from worksheet number 1. It's a quadratic equation. It has a constant. You're also given one solution of the equation, which has a constant in it as well. They want to know the value of the constant in the original equation, the c. We don't care about the k. All right, so the shortcut or the approach to this one is to notice a couple things. First of all, if you square out, or distribute the left side, and then get it equal to 0, right? Here we have it, a quadratic equation in standard form. We know that the sum of the roots is equal to negative b over a. All right? So therefore, that's going to equal the opposite of negative 8, just over 1, or in other words, it's going to equal 8. We also know the product of the roots is equal to c over a, which is just negative c over 1, or negative c. So then what you do is, you have to notice, okay, this is one root, and this is going to be our second root, because these roots come in conjugate pairs. Now you say, okay, the sum of these two roots, in other words, if I add these two things together, what do I get? Well, I get just 2k, because the radicals cancel out. Then you notice if I go ahead and I multiply these together, well, you can just type that into Desmos. It doesn't matter. You know what I'm saying? You don't have to bother like working it out. Basically, it's going to be, k plus 9 root 2 times k minus 9 root 2. So now you essentially have a system of equations, and we're just going to go to Desmos and solve that. So for example, we've got 8 left side top equation. We've got negative c, left side bottom equation. Then a tilde, right side top equation, 2k. Right side bottom equation, this is going to be the product of the two things. Don't have to close, it's already done. Okay, notice it gives us the value for k, which we don't even care about, but it also, more importantly, gives us the value of c, which is 146. So this is just an alternate way you could solve this. If you like this approach, think this is, I don't know, easier to understand or faster, that's fine. Yeah, first problem, a very common one, basically, where you have a kite, and you're asked to find the length of one of the diagonals, and really the values under the square roots for the two like line segments that make up the diagonal. So just to give you an idea of what the picture might look like. So here's A, here's B, here's D, and then down here is point C. So we have something like this. And the reason I drew it like this is because, okay, AB and AD are equal, and they each end up being 3. BC and BD are equal. They are each 19. The two diagonals, which are going to be perpendicular, basically because this is a kite, so they form a right angle. Okay, they intersect at point G. So point G is right here, and then GB and GD are each congruent to each other. They each have a length of 1. So this is a basic setup of what the picture looks like. Okay, now the length of AC, so this whole diagonal right here, can be written as root P plus root W, and they want to know what are the values of P and W. So one of these is root P, one of these is root W. So therefore, you're basically just figuring out, um, what's the value of the P, what's the value of the number under the root, what's the value of the number under the root, and then adding them together. So this is just basically a Pythagorean theorem question. The hardest part of this, honestly, is trying to set up the diagram and figure out what the diagram looks like. Because for the triangle on the left, we're just going to have 1 squared plus root P squared equals 9. So now we get 1 plus P equals 9, or P equals 8. So therefore, the actual side length itself is square root 8, but we're only concerned with the number underneath the radical, which, is going to be 8 itself. So this is root 8, but again, we're only concerned with the p-value being 8. And that's what we're going to add to w. And then if we do the same thing here, we've got 1 squared plus root w squared equals 19 squared. So w equals, let's see, 19 squared should be 361, and then minus 1, which equals 360. So again, the actual side length here is square root of 360, but we're really only concerned with solving for w, which is 360 itself. So now we can just add those together, and we get 368, and that is our answer for the problem. And just to show you one thing as well with Pythagorean theorem, it is so much easier if you don't want to do these things by hand or in your head. Just go to Desmos, and solve the equation using regression. All right, why am I putting 9? It's 3. So for the first one, 1 squared plus square root p squared tilde 3 squared. And notice right here it gives me p equals 8. And then we can do the exact same thing for the w equation. Slide this up. All right, and then you can just type p plus w, and there's your answer right there, 368. So you can do all the calculations just straight in Desmos, once you know what you're solving for. We have a pyramid. It has a rectangular base, not a square base. So that makes it a bit annoying in terms of the calculations. But if we draw out a picture, okay, we have something like this. Then we have the height coming down the middle. Given the height at 7, Okay, I'm going to make this side my 14 and this side my 12. Basically, that means we're going to have to calculate, two different slant heights. So this thing right here is going to be 7. However, looking at the other direction, this is going to be 6. So this slant height right here is basically going to come from 7, and sorry, just to mention, we also want to find the total surface area. So the area of the base is easy enough. I'll get to that in a second, but we need to find the area of all 4 of the triangular faces. So I'm going to set up some right triangles, use Pythagorean theorem to find the slant height, because the slant height for the triangular face will also be the height, which we use along with its base side to calculate the area. So the first one, notice it's 7 squared plus 7 squared, equals c squared. And this is actually going to be a 45, 45, 90 right triangle, so c is actually going to be 7 root 2. But if you didn't recognize that, that's fine. You can just go to Desmos, and we can just do the calculation in there. Let's call this one A. So there's the exact value, 9.89949. Actually, I'll use A just because I use that in Desmos. Okay, now when we look at the second one, this one's a little difficult to see, but this right triangle here, one leg of 7, one leg of 6, and a slant height that we're going to figure out. So this one's going to be 7 squared plus 6 squared. We'll call this one B squared. So B is basically going to be the square root of, let's see, 49 plus 36. Just looking at my values here. Should be the square root of 85. But let's just go to Desmos to confirm. Yep, square root of 85. 9.21954. And it doesn't matter. Like the decimal values, I'm going to carry the exact values over for the calculations. Okay, so now here's what we have to calculate. First, area of the base, that's 14 times 12. Again, we go to Desmos, that's going to be 168. I'm going to call that capital B. Okay, now for the two triangles, I'm going to find their areas. So one of them is going to be basically like the left and right triangles here. This one and this one. The area is going to be 1/2 times base times height, and the base is 12, and the height is the a value here. Basically the 7 root 2 or the square root of 98 or the 9.899, whatever. So I'm just going to do that all in Desmos and add it all up in there. And then the second one is going to follow the same pattern, 1/2 base times height, except now the base is 14 and the height is, this is B, the square root of 85 one, which is the 9.21954. So what I'm going to do is go to Desmos. Let's get rid of some of this. Move this over. Okay, so we've got one triangle. Area is equal to 1/2 times 12, and then we've got times the a value, and the other one, 1/2 times 14 times the b value. Okay, one thing just to mention before I continue now to find the overall answer to this problem. The camera froze apparently towards the beginning of this video. The audio should still be coming through fine even though the camera's frozen, so just be aware of that. Hopefully it'll be fixed in the rest of the video going forward. Alright, so now we can go ahead and find the total surface area here. Remember, there's basically two sets of triangles, on the left and right, two sets on the front and back. So basically I need to add together the area of the base plus the 2 times the, let's see here, A is the left and right triangular faces, and then 2 times C, which are the front and back triangular faces, to give me the total surface area, which is going to be 415.867. This question says to round it to the nearest tenth a centimeter, so therefore the final answer you would report for this would be 415.9. We're going to look at question number 6 now. So for this problem, you were given apparently a data set with a bunch of numbers and then a value of k for one of the values in it. And you were told that the mean and median of the data set were equal. And it asked you to find the value of k. So, excuse me. I'm going to be completely honest. I could not think of a way to do this without basically using Desmos. So if you take all the numbers and you write them out in ascending order, so we've got 11, 12, 13, 15, 17, 21. Okay, and then k is going to fit somewhere. So essentially, as it is right now, you could put k to the, there's basically 3 regions you could put k. Okay, you could put it in region 1, which is to the left of 15. You could technically put it in region 2, which is between 13 and 15. And then you could put it in region 3, which is to the right of 15. Okay, so basically, what you would, I guess the way you would actually do, what you would do where you'd set it up is, if you put it in region 2, I'm going to start in the middle with region 2. So you put it between 13 and 15. Okay, so that means it's some number between 13 and 15, and it means that that value is going to be both the mean and the median. So, and actually I just realized, yeah, this is actually not that bad of a problem to work out, but I'm still going to use Desmos to do the calculations. So essentially what we have is these 6 numbers added together, right, and then k, and then you're going to divide by 7. All right, and now since I'm putting it between there, I would have 3 numbers on the left, 3 numbers on the right, and this median k value right in the middle. So we'll call this is the middle scenario, okay? This is where k itself is actually the median. But this equation I set up is for the mean, okay? And again, we want the mean and median to be equal. We know the median has to be k, because that's the one number in the middle. Therefore, the mean has to be k as well. So I'm going to just solve this in Desmos. And let me see here what I get. So there's everything being added up. And I'm doing regression, and I'm going to set that equal to k. All right, so it gets 14.83333. So if I added 14.83333 to this data set, it would be the median. You know, it would be the 4th value out of the 7. And if I find, let me just duplicate this and just confirm. So now what I'm going to do is get rid of this. I am just going to find the mean of this. Except I gotta delete all the pluses. So hoping to just avoid having to retype all the numbers. Okay, so notice here, the mean of the data set. Let's copy this. Now let's just type median. All right, so I found a value of k for which the mean and the median are equal. So that's the middle scenario. So that's k equal to 14.83. Let's check the fraction. Scroll down here. 89 over 6. Okay? So either one of those. So that's one acceptable answer. But there are two other cases, excuse me, where this would work as well. So one case is that, so this is the middle. I'm going to call this the left case. This is basically if you put it in region 1. So now, I'm not going to bother rewriting this whole thing. The average would be equal to the median. And now if you add k over here, somewhere over here, we don't know where exactly, then the median value would be, well, we'd have three numbers here, we'd have three numbers here, then the median would be this 13. So now the mean also has to be 13. So now you can take this statement, this equation, go back to Desmos. So let's say, okay, now I want this median value to equal 13. What does k equal? Well, it has to equal 2. The mean, does the mean of all these new values equal 13? Yes. Does the median equal 13? Yes. Okay, so the correct answer, another possible correct answer would be k equals 2. Now we also have a scenario where we could put it on the right as well. So now if we look at the right side, this would be region 3, in the picture up here. So let me get rid of this. So now get rid of this. K is somewhere over here on the right. That means the median is going to be, let's see, 1, 2, 3. So we got 3 here, and counting 1, 2, 3 here. That means the median would have to be equal to 15, which means the mean would also have to be equal to 15. So now we can just go back to Desmos. Let's set equal to 15. Okay, so what is our k value? It is 16. Is the median of the new data set with k 15? The mean, excuse me, 15. Is the median 15? Yes. So there are 3 different answers. Looks like, at least based on the way that I set up this problem, there are 3 different answers or values that you could choose. Positive 2 works. 14.83 or 89 over 6 works. Positive 16 works as well. So at least for this problem that I've created, all 3 of those would be considered correct answers. Same worksheet, August 2025, worksheet 5, question number 6. This is the one where you're given a data set. It's got a constant in it. You're told that the mean and median are equal. Find the values of k. All right, so there were several suggested methods that you could do to do this in like a quicker approach, than I did. And that's great. One of them is to just take, let me see what I did. Okay, so just type in literally the 2 operations like this, and notice it'll automatically give you a value, okay? For the median to equal the mean, k has to equal 2, and that's one of the acceptable answers. Okay, what about if I tell it k has to be greater than 2? Well, notice it's not working. Let's go here. Okay, k is greater than 2.1. It returns 16, so that's another possible value. I think there should be a third solution. I'm not sure why it's returning. It's supposed to be like 14.83 repeating, but in any case, that gave you at least 2 different possible solutions right there. Now, one variation of this you technically could do, just to make the typing quicker, is you could technically type a list and put all the values in the list, like this, and then you only need basically to type the numbers once right here, right? Notice here it's just, much faster and quicker to type. You only type the numbers once and then median A, mean A, get that. So that's a slight variation. Now, a second alternate way you could approach this would be, I'm actually going to back up here. Probably would have been quicker just to type all the numbers out anyways, but okay. Let's duplicate this. All right, second alternate approach you could use would be to graph both of these as y equals the median of one and y equals the mean of the other. And notice you get these 2 graphs. See if I can change the color here. Okay. The intersection points are your solutions. Okay. And notice the input values, which mean the x values, that's what you want. Like the 2 is the solution here, not the, the y value. That's the actual median value. And notice here, technically, here's the 16 that we found before, and there's also a 14.83 repeating. That is a solution as well. So this is an alternate approach that you could take to find the answers to this problem as well. All right, let's move to the top of the next page now. Question number 7. Here we have a line which is passing through some points. R0, basically the x-intercept, 0t, the y-intercept, x-intercept, y-intercept. And it wants to know which of the following is equal to k. All right, so if you're going to do this by hand, basically what I would do is I would note that the slope of this line using y2 minus y1 is just t minus 0 over x2 minus x1, 0 minus r, t over negative r. Excuse me. And now you could set that equal to the slope of the equation, which, if you know the shortcut formula, it's negative a over b. In other words, it's negative k over 4. Or you could rearrange it. You could subtract over kx and then divide by 4. So however you get it, this slope is now equal to negative k over 4. Okay? So what is k equal to? Well, we cross multiply, we get 4t equals, the two negatives cancel, so we get kr. Divide by r. Okay, k equals 4t over r. All right, except the problem is we don't see any of those values in the answer choices. So now what do we have to do? Okay, so basically what you have to do now is you have to solve for the value of t, which you can do to get a numerical value in the original equation, and then you're going to plug that in, and then it's going to simplify to just an expression in terms of r or t. It'll really be in terms of r. So 0t is the point. So the equation is k times 0 plus 4, you could put t here, equals 13. This whole thing drops out. Therefore, t is equal to 13 over 4, i.e. the y-intercept is 13/4. So now you can plug that in, and the 4's cancel out, and k is equal to 13 over r. Correct answer for this problem is going to be letter A. Now, you could also do this problem in Desmos using the strategy of picking numbers, and here is how I would do it. Let's see, what number did I pick for k? Oh, I think I just said, yeah, k equal 1. So let's set k equal 1. Okay, kx plus 4y equals 13. I'm going to go to my graph. Okay, so this is 0 comma t. That means t equals 3.25. Then my x-intercept over here, this is my r value. R equals 13, just get rid of that. It's trying to graph a circle. Don't worry about it. Okay, so now I set, these are the values I get when I set k equal to 1. So as I go through the answer choices, hopefully only one of them gives me a value of 1. So A, 13 divided by R, that's 1. Okay, so that works. 13 divided B, 13 divided by T, positive 4. Not it. C, 4 divided by R, some random decimal. Not it. D, 4 divided by T, 1.2307. Okay, clearly the answer is A. It's 13 over R, and that's how you could solve this one, basically by using Desmos along with picking numbers. All right, let's look next at question number 7 from the same worksheet, August 2025, worksheet number 2. This is where you're given an equation of a line with a constant in it. You're told it passes through some points, more constants. Which of the following is equal to k? All right, so the approach is we set up a list with x1 and y1 using the 2 points that were given, 0 comma t, Okay. And then we're going to do a regression with the given form of the equation, which is this. The kx plus 4y equals 13. Make this y1. Okay. So notice it automatically found here the values for r and t and k. So which of the following is equal to k? All right, well, k is 13. So now you can just easily type them all in. 13 over r. Is that 13? Yes. Okay, so it looks like that's our answer. Let's just check 13 over t. Not our answer. Okay, 4 over r, obviously not our answer. 4 over t. So that's it. So this is a much faster, quicker, easier way that you could solve this one. So thank you to the person who suggested this one. Again, name should be on the screen at the bottom. All right, let's look next at question number 6. So in this one, you're told that basically you have the price of some item. I chose a concert ticket. And it initially was like tried to be sold at some dollar amount, and none were sold, at that dollar amount. Then, they started decreasing the price by whatever, some amount. I chose $1.50. And as you do that, the number of things, in this case tickets, increases by 1. So for every $1.50 drop, the number of tickets increases by 1. Again, probably not a realistic scenario for the numbers I chose. For concert tickets, this might be like increases by 1,000 or something. But just worry about the actual methodology we use to set up and solve the problem, not how realistic it might be in real life. Okay, they give you the total revenue, and they want to find out how many tickets were sold. So first of all, revenue is going to be equal to the price of a ticket times number of tickets sold. Okay, so we have to come up with an equation now to solve. We know the revenue. 38 times 30, 1348 times 50. Okay, the number of tickets sold is going to be x. That's what we're going to end up solving for. The price, however, basically it's a linear function. And essentially what's happening is you start at 90 and then you subtract 1.5 or 1.50, if you want to use that, x. Because essentially what's happening is like this change, like the tickets sold increasing by 1, tickets sold increases by 1 for every decrease by 150. So that essentially becomes like your slope in your formula. The minus 150 over 1, plus 1 on the bottom here, minus 150 on the top. So that, like, this minus 150 over 1, this is like number of dollars, and this is, say, number of tickets on the bottom, and you multiply that by x, which is a number of tickets, and notice that leaves you with a number of dollars overall, which matches the $90, that the price that we're starting at. So this whole thing will be in dollars, which represents the price. Okay, so basically now that you have the setup, you can solve this by hand if you want to. I instead would just go to Desmos. So what I would do is, let's first clear this. There's multiple ways you could do this. You could just type it. Get that out of the way, and then we can look for some vertical lines. Those are the solutions. So notice here there are actually two solutions because this is a quadratic. So there's actually two different number of tickets sold that come up as correct. You have 29 and 31. So either there's two correct answers to this problem, or the other possibility is that this was a multiple choice problem and only one of these was listed along with 3 other incorrect answers. So either way, this is the method, this is the method that you use to solve it. This is the equation you set up. Basically, it's like the starting price minus the, whatever the decrease in price per ticket sold is, whatever that dollar amount is, times X, which is the number of tickets sold. That's the price. And then multiplied just by another X for the number of tickets sold, because the price of a ticket times the number of tickets, that's how you get your total revenue. first problem, you have a scatter plot. It has 9 points graphed in it, and there's a line of best fit. And this question wants to know, okay, you take one of the existing points on it, and you replace it with another new point. What could be the equation of this new line of best fit? All right, so you can see the original line of best fit, kind of like fit to these 9 points. And then what's going to happen is the 5, it looks like it's about 512 point, is going to instead go down here to 50. So what's going to be the end result? Well, basically what's going to happen is to account for this point that's like way far below, or maybe on the test you had one where the point was like extremely far above the line of best fit, is the slope of the line is going to change to accommodate that. So in other words, down here at 50, this new point is going to pull the slope down, and so instead it's going to get slightly flatter. I mean, this is most likely an exaggeration. It's not going to be that much of a change. Um, but the point is, it's going to, basically the slope, which is positive, is going to decrease. All right? That's the overall end result to account for this point down here. So the way I would approach this is I would go, basically I would find out an approximate slope for the existing line of best fit, and then compare that to my answer choices. So for example, here's a point that looks like it is about roughly 5, 12. And then over here at the y-intercept, we have a point which looks like it is about 0, 7. All right, so now if you just go ahead and calculate the slope between those 2 points, you get, wait, I'm not doing this correct. What am I doing wrong here? 11, 12, sorry, it's 5, 13. Why did I say 5, 12? It's 5, 13. I even have it down in my notes here. It's 13 minus 7, which is 6 on top, over 5 minus 0, which is 5 on the bottom. Okay, the slope is 6 over 5, or 1.2. Okay, that's the approximate slope of the current best fit line with this 5, 13 point put in there. All right, so if the slope is going to decrease, now if you look at the answer choices, there's only one answer choice that could realistically be it. Okay, and it's going to be this one right here, because this is the only one with a slope which is less than the existing slope. Like, moving a point down here will not cause the line to get steeper, and that's what's happening in A and D and in C. All of these slopes are greater than this estimated, slope. So therefore, it has to be B by process of elimination. But now let's actually look in Desmos and see what would actually happen if we tested out by doing this. So what I've already done, just to save time, is I've gone ahead and I've already graphed out, I think, what the actual equation of the line was that I used to generate, this line of best fit, which is 1.17x plus 7.16, okay? So what you're seeing, let me just zoom out here a little bit so we can get a better, okay. So what you're seeing on the screen now is not the actual points here, but it's basically not the points from the scatter plot, but the points that are on this actual line itself. And I'm going to show you, okay, what happens if we take the 513.01 point away and we replace this with 5, 0. And then we'll do a regression and we'll just confirm that the slope does in fact decrease. Okay, so let me just slide this up because I need some more room. What I'm going to do now, I can't copy this table because this table is being autofilled. So technically I have to make a new table. And you don't need to do as many points, but just for demonstration purposes, I am going to do this. And now I'm just going to basically copy all these points down. Okay, except at 5, I'm going to make its y value 0. And then everything else should be the same. Okay, so if we look on the graph over here, notice there's a bunch of red points and there's only one black point where it's, and I'm also just, to avoid anything, let me see here. Oh, that's just x. Okay, so I got x1, y1. Now, when I do a linear regression for a line of best fit, right, y equals mx1 plus b. Okay, so what happens? First of all, notice the slope decreases. So that for sure happens. But also the b value shifts down as well. Okay? So the y-intercept goes down, but the slope also goes. The slope decreases, it gets flatter, but it also causes the entire graph to shift as well. So both of those things happen. Now, the problem is, if you go back and look at the answer choices, right, only one of them has the slope decreasing compared to the existing slope, with the estimated existing slope of 1.2. However, technically both B and C have like the y-intercept value decreasing as well, i.e. like shifting down. So you can't use the y-intercept result solely to like eliminate all the answer, 3 wrong answer choices and just get one. The point is, you could first look, if you realize that the y-intercept is going to shift down, you could eliminate this one and this one, but then you still have to know how it's going to affect the slope. And more importantly, you have to get an estimate for the slope of this existing line to determine which way it's going to go, and to know that 1.1 is going to be the slope value, which is less than it. So that's just a demonstration in Desmos of what actually happens if you basically take the exact same points, but you replace one of them with a new point such that it is significantly below the x-intercept of the line, or sorry, existing point on the line. It causes the slope to decrease, and it causes the y value to decrease as well. Now, just hypothetically, let's say instead of 5.0, let's say it went up. Say it was now going up to like 5.26. And now you can see the opposite happens. The slope increases and the y-intercept increases. Okay, so they both go up. So just if you had the opposite question for this, where the point was above the line, you would expect both the slope and the y-intercept to increase. Okay, that was a long problem. All right, let's look at the next one. 18, number 2, we have a fourth degree polynomial here, and they tell you it has a factor of this, where a and b are integer constants. That just basically means that it can be factored. What's a possible value of a plus b? So there are multiple ways you could do this. One way to do this is just to go ahead and just factor it and be like, okay, well, it's x squared, and let's see, it's going to be plus and plus. 63 is probably going to be 9 and 7. I mean, I don't know, but we'll just, rather than 63 and 1 or 3 and 21, but we'll start with 9 and 7. And let's just pick, okay, 2 and 4 and see if this works. So let's check. 9 times 4 is 36. 7 times 2 is 14x squared. Does this add up to our middle term? Okay, yes, it does. Therefore, this is the correct factorization. So there's two possible answers for this, right? Like this could be your a and b for this parenthesis here, or this could be your a and b. So you could have 2 times 9, which is 18, or you could have 4 times 7, which is 28. So those are the two correct answers. That's how you can solve this by hand. Now, if you wanted to do Desmos, and I'm sure that people are going to be able to suggest some easier techniques than what I'm going to show, but these are the only things that I could think about or figure out just initially. So if you try to do, say, regression, problem is you got C, you got A, you got 4 different constants that you're solving for here, right? Gotta make all these x1. Okay, so this is obviously not correct. I gotta put in x1 equals. Okay, what's gonna happen is it's just going to find any values that work. And see, these are not integers. So it's like, so I'm having difficulty figuring out how do I force it to make a, b, c, and d into integers. Now, what about if I make this a squared and just an x, and then just, because the numbers will still be the same. It would just be a quadratic instead of a fourth degree. But notice, same thing happens, right? It's still integers. So they're still not integers. We want integer values for, the a's and b's and stuff. So what I would do instead is I would go ahead and I would take the function. This is the only way that I figured out how to do it entirely in Desmos. And okay, so you graph the function, and you're looking at this graph, and you're thinking, okay, well, I'll look for the x-intercept values. You can use x-intercept values to get to factor a function. Okay, except in this case you can't, because notice there are no x-intercepts. Because notice in the factored form here, right, you get basically 2x squared equals negative 9 if you try to solve it, or 4x squared equals negative 7. They're all complex answers. They're complex numbers, so it doesn't, you know what I'm saying, that doesn't help you. There are no x-intercepts. So what I said instead was, let's just turn it into a basic quadratic. Now, so in other words, these parentheses are now 2x plus 9 and 4x plus 7. Now there are x-intercept values. So notice here, okay, I export these values, right? Negative 1.75 and negative 4.5. So essentially that means if I was going to write this in factored form, and again I'm using the quadratic technically, not the fourth degree, but it would be like x minus negative 4.5 and x minus negative 1.75. So first of all, the two negatives become positive. So make it a plus. Then I'm going to convert each of those to their fractional equivalents. Get rid of this, get rid of this, and actually since I want it to be positive, let's just get rid of the negatives. Okay, so we got 9 halves and 7 fourths. So it's like x plus 9 halves and x plus 7 fourths. And then the way you actually get them into like the a and the b is we just clear the fractions. So for example, here you multiply everything by 2, and it just becomes 2x plus 9. And then here you multiply everything by 4, and it becomes 4x plus 7. So that's how you could get the a and b values in Desmos. It's, again, a little bit of a workaround going it from a fourth degree to a quadratic, and then you can just add the squares on, because that just changes the degrees of the x's. That doesn't change the factoring or the coefficients of it. And then you've got a times b is 18, or a times b is 28. So if you have another method, that's shorter, quicker, easier in Desmos, basically to factor this fourth degree polynomial, go ahead, post it below. I will do an update, of course, with alternate solutions at some point. So I want to show two different things about this. Basically, two different methods to essentially factor this in Desmos, because they were not really shown in the first version of the video. And factoring obviously is something that is now part, like I said, of my Ultimate Desmos Guide to Digital SAT Math. So it's now something that is very common and would be included in the solution to a problem like this. All right, so what I'm going to do first, and this is just basically general factoring. This is not necessarily a specific solution suggested by someone, but we're going to just go ahead and factor it, and I'm just going to use like C and D here, A and B and C and D for my various constants. And we're going to add an element list for x1, of course. Okay, but notice, right, it's giving us all decimal values. It's not giving us nice whole integers, which is what we want, what we expect. Okay, so this is basically the trick that you have to do. Again, this is covered in more detail in my Ultimate Desmos Guide video that looks at factoring. So A and C, here, are basically two factors of 8. So we've got either 1 and 8 and 2 and 4, various combinations. So I'm going to start with A equals 1. Now, what I'm looking for is all of the other 3 constants to be integers. If they are, then I have a proper factorization. Then I can basically get a value and answer the problem. But that's not the case here, because b is 4.5, which is not an integer. So this is not an appropriate factorization. So now I could try 2. Notice I do not get an appropriate factorization either here. Okay, what about 4? Okay, now it does give me factorization. They are all going to be integers. So that means I have potential answers of 28, right here, A times B, or technically also C times D, which gives an answer of 18. Like, essentially what's going on here is, it says it has a factor of ax squared plus b, But this parenthesis could technically be either of these factors. In other words, it doesn't matter which of these factors I call A, which I use A and B in versus C and D. The point is, the A times B here is just a coefficient of an x squared term times the number that's added to it inside one set of parentheses. So this question will have two correct answers, 18 and 28, and that's how you can do the full factorization in Desmos. Now, here is an alternate method. This was suggested by someone, by a comment on the channel. What you could do also to factor this is you can do the following. All right, I'm going to need to do, it's going to be another regression. It's just going to be slightly different. Okay, that has to be squared. Okay, and then I'll explain what I'm doing in 1 second. Okay, so basically what I've done here is, technically I have factored this expression into intercept form, okay? And so P and Q represent my two x-intercepts if you were, theoretically or whatever, to like, say, graph this out. I mean, they're not going to be x-intercepts because technically they're complex. They correspond to complex roots. They don't correspond to real roots or real solutions. But it's the same. Essentially, it's the idea or concept of factoring this into intercept form. Okay. So with that being said, and I have an m pulled out here, and of course m is the 8. So in other words, what I'm really doing here is I'm factoring 8 out of everything, and then the remaining thing, which has a 1 for the leading coefficient, is being factored into intercept form. In this case, x plus 4.5, x squared plus 4.5, and x squared plus 1.75. Okay, so it's x squared plus 4.5, the 8's out front, x squared plus 1.75. However, if you convert those to decimals, 4.5 is 9 over 2. 1.75 is 7 over 4. Again, you could, if you don't know this, you can just go to Desmos and just type each one and then click the fraction button. So now what you do is you take the 8 out front and essentially you distribute it in order to get rid of these fractions, in order to make these integers. So essentially, the first parenthesis, you're going to have to multiply both things by 2. That's how you're going to cancel out the 2 down here. Then the 8, if you're pulling a 2 out to multiply that by the first parenthesis by 2, there's going to be a 4 left over, and that matches the second parenthesis because that's what you need to cancel out or reduce the 7/4 to an integer. So what ends up happening is then, notice you multiply through by 2, you get 2x squared plus 9. You multiply through by 4, you get 4x squared plus 7. Now notice we get the same answers. This times this, 28. This times this, 18. This is just a different or alternate approach in order to factor this expression. That's basically all it is. So if you want to use this, you can use this. If you didn't follow this at all or don't understand it at all and want to use the first approach, totally fine as well. Just wanted to share this, with people that may be interested in it. Being said, let's go ahead and get started here on question number 1. This was a very popular question that came up, the one about like vitamins and so many ounces of cheese and so many ounces of tuna, and essentially you have to construct an equation that represents the total ounces of this vitamin that you would get for eating, let's say, X ounces of cheese and Y ounces of tuna. All right, so we know that the basic relationship, okay, for cheese, it's 3 ounces of cheese to 1 ounce of this vitamin. And then for tuna, it's 1.2 ounces. I'm just using OZ to abbreviate ounces to 1 ounce of the vitamin. Okay, so really what you have to do here is you have to find essentially the unit factor. And what I mean by that is how many ounces of the vitamin do you get per 1 ounce of cheese or per 1 ounce of tuna? So that's really where you're just dividing, both sides by these values. The reason we do that is because, so this is 1 ounce. This is technically 1 over 1.2, which if we go to Desmos, you'll see that this actually reduces to 5 over 6. So, sorry, the reason we do that is because if you want to find out how many ounces of the vitamin you would get from eating X ounces of cheese and Y ounces of tuna, basically we get the unit basically the unit amount, the unit conversion factor right here, and then we're just going to multiply that by X. So for example, 1 ounce of cheese, 1/3 of an ounce of vitamins. Now if I wanted X ounces of cheese, right, I would just multiply this by X. X times 1 is just X. And then the same thing over here, you multiply it by X, so that just becomes X over 3. Or, as you can see in this equation right here, 1/3 X. And then similarly over here, if you wanted for the tuna, if you ate Y ounces, you just multiply this by Y, and then you do the same thing to the other side. So you get 5Y over 6, or 5 6 times Y. So the correct answer for this one is going to be letter C. And that's pretty much the only way, at least the main way I can think of to reason through it. If you have another alternate approach, I mean, that's fine, leave it below. But this is the main way to kind of theoretically work your way through the problem and figure out what the correct equation is going to be. Look at the next one. Let me erase some of this work just so we can read the problem nice and clearly. Okay, so question number 2. They give you this function, and it's an exponential function. And it says it's greater than k for all values of x where k is a constant. What's the largest value of k? So what's really going on here is essentially a horizontal asymptote. Because if you graph this out, and this is just going to be easier to, I think this is going to be easier to demonstrate visually than like just describing it. It's an exponential function. It goes up, it's increasing to the right or decreasing as you're going to the left. You just zoom out, here's a better picture of it. So as the x value gets smaller and smaller, i.e. as you get increasingly negative, this whole first term right here, the 6 times 2 to the x, just goes to 0. So like this whole thing right here, as the x value gets negative, it then becomes 6 over 2 to the x, but it's positive because you would flip it. And the point is, this whole term essentially turns to 0, drops out, disappears. Therefore, this 1/27th acts as a horizontal asymptote. And so the answer for this, the largest value of k that everything is greater than is technically 1/27th. Now you could also put it in it as its decimal equivalent if you wanted to. So you could enter basically 0.037. You could also enter 0.0370. I don't know if that would, I mean, I guess entering that last 0 doesn't really matter, but because I guess technically you would because it doesn't terminate, so I guess you technically would need to fill up the entire thing even though it's, just a 0. But anyways, this is the answer. And the real reason is because like with a standard exponential function with no vertical shift, like if this wasn't here, right, it just approaches 0, whether it's going, whether it's an increasing or even if it was a decreasing. It essentially has a horizontal asymptote at y equals 0. So this just shifts it up to basically 1/27th. So the correct answer for this is 1/27th. All right, let's look next at another problem that's going to be easiest to kind of, I think, visualize from the graph. So I'm not going to bother kind of like doing this by hand or going through the theory. I'm just going to graph it and see what happens on the graph because, again, I think it's much easier to understand what's happening here via the graph. So there's the original function 27x cubed, right? It's a cubic polynomial. Just zoom this, size this down a little bit. Okay, so there it is. Now what we're doing is we are basically replacing x with a negative x. So that's going to cause it to flip, essentially a reflection across the y-axis. and we're adding a value to it, and the key is this value is a positive number. So let's just say c is equal to 2. All right. The x and y intercepts of the new graph, so let's just take away the old one, we only want the new one, are r comma 0 and 0 comma t. So what's true about r and t? Basically what they want to know is, are they both positive, both negative, or is it some combination? All right, so we can just easily see here from the graph, okay, the y-intercept is obviously positive, right? In the original function, it's 0, 0. Now it went up by a positive constant, so now it's going to be greater than 0. So t must be greater than 0 for sure. So I can get rid of this, and I can get rid of this. Now the question is, what is happening with the r value, or the x-intercept? Well, you can see here, basically, if you only did the shift, if you didn't do the reflection, if you only flipped it right, then the x-intercept would be like over here in the negatives, but because of the reflection, that's why it flips over to the positive. So r must be greater than 0. Therefore, the correct answer for this problem is just going to be letter A. Basically, they are both going to be positive. And again, I think it's easiest to just graph out the function in Desmos to visually see, what's happening with both of them. All right, next up, we have a circle problem. And in this one, you are given an equation. It has some constants in it. And essentially, it's asking for an expression for the radius in terms of A. So if you want to do this one by hand, what you would do is you would complete the square on x and on y. So I'm going to add 2 blanks. And then over here I have 40, and I'm going to also add 14a. All right, and then technically there's going to be 2 blanks over here as well. So completing the square, we take the b value, or the middle term, we divide it by 2. That negative 2a will then become negative a, and then you square it. And then that goes in the blank here. That's going to go in the blank here. Sorry, it would be a squared. That's what goes there. That should be a squared. All right, then for here, negative 6 divided by 2, negative 3. That b over 2 term gets squared, so I get a 9. I get a 9. Okay, the left part doesn't matter. All I want to know is, what do I get on the right side for the radius? So it's a squared plus 14a plus 49. This is going to factor, okay, as a plus 7 times a plus 7, or a plus 7 quantity squared. But remember, in the standard form equation of a circle, it is x minus h squared plus y minus k squared, blah, 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 equals r squared on the right. So this is equal to r squared. Therefore, r is equal to the square root of this, which is just a plus 7. It's letter B. It is not letter D. Okay, now let's see how you could solve this in Desmos. So I am going to go to Desmos. I am going to do circle regression. So I am going to, and it's going to take a little while to type out because I got to do x1 and y1 for every term. Minus 6y1 minus 14a minus 40. So I take the original equation, I get it equal to 0. Then I'm going to do regression to the standard form. Okay. And now what I need to do is I need to define a list, an element list for x1 and y1. It's going to be much quicker if you pick a number and pick its opposites. So like I use 10 and negative 10, and then I pair them up so that I get each combination of numbers with each other. Now, excuse me. So what I need to do is the following. I have a value for the radius, okay? It's telling me the radius is 2.44, how many? 2.4, yeah, 2.44481. All right. So all I need to do now is I need to take the value for a that it gave me, and I see which of these answer choices equals 2.44481. So if I do a minus 7, not equal. A plus 7, yes, is equal. Notice it's 0.81 in the regression statement because of rounding, but down here you see it's technically 0.8086 8799 blah, blah blah. Anyways, so that's it. I mean, if you take this and square it, it's obviously not going to be 2.44481, and same thing with a minus 7 squared. So this is how you could do the problem entirely in Desmos. And just the last thing, if you want more information on doing regression of circles, check out my ultimate Desmos guide to digital SAT math. I will post the thumbnail on the screen in this video, which has the specific section of it that goes through how to do that. 2025, question number, worksheet number 1, question number 4, this one here dealing with a circle. So this is a so much faster and quicker, shorter method than what I demonstrated in the video using circle regression. Okay, so all we're going to do is we are going to go to Desmos. We are going to type in the equation for this circle. We are going to choose a value for a. I'm just going to default to a equals 1. Next, I'm going to find the radius of the circle. So I'm going to find the max and min points. Make sure you choose those. You do not want to choose the y-intercepts. And then I'm just going to call 1a and 1b, and then I'm going to find the distance between them. And of course, I'm going to divide it by 2 to get the radius distance, because the full distance between them is the diameter. All right, so the radius of this circle is 8. When I let a equal 1, the radius value is 8. So now just go run through these answers. Which of these is equal to the radius value of 8? Well, 1 minus 7, negative 6. No. 1 plus 7, 8. Yep. 1 minus 7, negative 6 squared, 36. No. 1 plus 7, 8. 8 squared, 64. No. Correct answer is B. Again, this is just a faster, quicker way to solve this. Of the next page, question number 7. Okay, so here you have an exponential function, and you're being told that every time you increase the x value by 4, the f of x or y value increases by, whatever, p%, by some value. All right. The question wants to know, okay, for all these various other functions below, which one of those shows this same increase amount when you increase the x value by only 1? Okay, so first I'll talk about the theoretical way, then I'll show you how you could actually go into Desmos and calculate it and figure it out, with, say, actual numbers. All right, so the theoretical way basically says, all right, if you're increasing x by 4, let's say x is going from 0 to 4, okay? So that means you're going from like 18, times 2.4 to the 0, which is just 18 times 1, or 18. And then 18 times 2.4 to the 4 over 2. All right? Well, 4 over 2 just divides into 2. So therefore, notice what's happening here. Basically, you have the same 18, and you're going to end, when you increase x by 4, you end up multiplying it by 2.4 squared. Okay, so what is 2.4 squared? Well, if you don't know it off the top of your head, it's just 5.76. So in other words, what's really happening is you're taking 18, you're multiplying it by 5.76 for every increase of x by 4. Okay? It doesn't matter what p% is. It doesn't, we don't actually have to calculate what the percentage increase is. All I have to know is what happens to the y value when I increase x by 4. So when x goes from, say, 0 to 4, y basically gets multiplied by, choose a different thing instead of x, by 5.76. So now, when you look at these possible answer choices, okay, when you increase x by 1, so in other words, if you go from 0 to 1, which of these is going to result in multiplying the n value by 5.76? All right, obviously it is going to be right here, letter C, which is, your correct answer. Now, let's look at some actual, if you didn't quite follow that, that's fine. Let's look at some actual numbers, and I'll show you how you could actually calculate the percentage increase, the p%, and then figure it out basically from there. Okay, So what I would do is I would go to Desmos, and I would say, all right, I have my original function here, f of x equals 18, and then I've got 2.4 to the x over 2. All right. So now x is increasing by 4. So I'm going to find the percentage increase. In other words, I'm going to find what p is when I go from 0 to 4. So percentage increase formula would tell us do f of 4 minus f of 0, basically new minus old over old, or divided by f of 0. Okay? Then multiply that by 100 to turn it into a percentage. So in other words, the p here, like the p percent increase is 476, percent. Now, if you think about that as a decimal, of course, that's just equivalent to the number 4.76. Now, go back to exponential functions. Think about how exponential functions are set up, right? You have like the initial amount out front, and then it's like 1 plus or minus r, which is your growth rate or your decay rate if you're decreasing, and then up here you have like, whatever your exponent, which for these it's just going to be x. Okay, so we want something that will have a 476% growth rate. Okay, so that as a decimal is 4.76. That means first of all it's going to be plus, not minus, and second of all the r value is going to be 4.76. That's what you're going to plug in here. So therefore, you combine those together, you get 5.76, to the x. So that's a second way you could do this. You could think about it. Here is also a third way. Okay, will take longer, it will take more time, but still you could just do this, brute force it basically if you wanted to. All right, original function, like I already showed, increasing x by 4, p is 476%. Let's go through the answer choices and so I'm just going to move this up here. First of all, I'm just going to let n be whatever. I mean, we can just let it be 18. It doesn't have to be 18, but we'll just make it the same number. Okay, now what I'm going to do is calculate the percentage change when I increase x by 1. So in other words, when I go from x is equal to 0 to x is equal to 1. Okay, so increasing x by 1, what is the percent increase that I find? Notice for answer choice A, it's 140%. That does not match 476. Okay, let's check out B. It's 376%. Notice that does not match what I got for the original function, which is 476. So that's wrong. Also, you're probably noticing now that the percent increase is technically like 1 less than the number you see inside here. I mean, technically multiplied by 100, right? 476 minus 100 is 376. Okay, let's check C. 5.76. Okay, now here, increase x by 1. What's the percent change? 476. That matches the same p-value I got for the original function, increasing x by 4. That is the correct answer. Last one, just to show you that it is not correct. This one, it's increasing by what? 1,282.4%. Okay, clearly wrong. But that's a third way. That's, kind of like a third approach that you could take to solve this problem. So, this is a factoring question. They give you this fourth degree polynomial. They tell you it's equivalent to this factored form where j and n and p and k are integers. And then they want to know which of the following cannot be an integer. Okay? So in other words, which of the following must be a decimal, essentially. All right. So first thing I would notice is that there is something out here in front, right? This is a common factor. So this has to be, the only number that is possible for j is 2, because you have a 3 inside here already. So if you like FOIL this out, this times this would be 3x to the 4th. So the only thing you can have out front here is j to make 6x to the 4th, and the original expression is a 2. Okay, so right off the bat, I know that j has to equal 2. All right. So now I also know it's going to look something like this: x squared plus n. Okay, 3x squared plus n, x squared plus k. So This is not necessarily the quickest or easiest way, but I'm just going to show it to you. Just basically, it's like trial and error. So when I was going through this, I basically made a little table. And I put J, and I put N, and I put K, and then I put P. Sorry, I put P over 2, and I'll explain what that is in a second. And then lastly, I put P. Okay, so essentially what is happening here is I'm going to run through all the different possible factorizations that you could have. How many different things do I need? 1, 2, 3, 4. It looks like I need a total of 6. Okay. So one other thing just before we begin. If you pull a 2 out initially as a GCF, you're going to have 2 and then 3x to the 4th plus, and notice the p would get divided by 2, x squared, and then plus 63. Okay? So this is what's being factored into the 3x squared, x squared, nk. So first of all, okay, so now I can fill in the table. J is 2 always. N and K are going to alternate as different possible factors of 63. So N could be 7, which would make K 9, or N could be 9, which would make K 7. N could be 21, which would make K 3, and N could be 3, which would make K 21. You know, the opposite, just switching the numbers. N could be 63, which would make K 1. N could be 1, which would make K 63. Okay. Now, basically what I'm going to do is, notice to get the P over 2 value, like, you know, in here. Technically, I'm doing FOIL, but I'm really only doing the inner and the outer terms. So this formula is really, it's like N times 1 plus K times 3. Or it's really N plus 3K, if you think about the FOIL, right? And this you could just automate in Desmos if you wanted to. But I'll just do it here, and I'll just tell you, you know, basically what the numbers are. So N plus 3K. 7 plus 3 times 9. 7 plus 27, 34. Next, it's going to be the opposite. So it's going to be 9 plus 3 times 7. 9 plus 21, 30. Then we're going to do N 21 plus 3 times 3, or 21 plus 9. It's also 30. Then we're going to do 3 plus 3 times 21, which is 3 plus 63, 66. And lastly, 63 plus 3 times 1, which is also 66. And then 1 plus 3 times 63, that is 1 plus 189, which is 190. So these are all the values, basically, that you would get for this term. But in the original equation, you have to multiply these by 2, you know, because we factored a 2 out. So really, P here is 68, 60, 60, 132, 132, and 380. Okay. So which of these cannot be an integer? So when you run down these, you're looking for, like, you know, whatever over whatever. Can you make an integer in any of the rows? So A, N over J, okay? Odd over even. 7 over 2, integer. No. 9 over 2, no. 20 over 2. Notice they're all decimals. 3, odd over even, no. Odd over even, no. Odd over even, no. So that is the correct answer. But just to show you, N over K. All right. 7 over 9, integer, no. 9 over 7, no. 21 over 3, yes. 21 over 3 is 7. It can be an integer. Therefore, it is not the correct answer. Let's look at P over J. J is 2, so you only have to find one value of P that divides by 2. Well, all of them divide by 2, you know, because 68, 60, 132, 380. So therefore, that one's out. K over N, you can just use now the exact same process that I was doing before, just now make K 21 and N 3. You know, 21 over 3, 7. Yes, can be an integer. Therefore, correct answer for this one is letter A, N over J. All right, let's look now at question number 3. Here we have a circle. And on this circle, we've got some points, and then specifically we'll have some arcs. So now we need to put the points on the circle such that when we draw out the angle, we have a 152.6 degree angle, which is going to be a pretty large obtuse angle. So, I mean, it doesn't have to be to scale, obviously, but like I drew mine something like this up here. Here's x, y, okay, and here's z. So this, pretty large, whatever. This is 152.6 degrees. Okay. What is the sum of arcs xy, so this arc right here, and yz, this arc right here? Basically, what you have to do for this question is, first, you have to know that the measure of an arc is equal to double the measure of its corresponding inscribed angle. That means the measure of arc xz, so right here all the way around in orange, from here to here, okay? So the measure of arc xz is going to equal 2 times 152.6. An alternate way you could think about it is the measure of the angle, an inscribed angle, is half the measure of its arc, but we know the angle, we want to find the arc, that's why we double it and not half of it. Okay. So if you go ahead and do this, you should get 305.2 degrees. So that's the total measure of this orange arc. Therefore, the measure of these two other ones together is just going to be 360 minus that, or 360 minus 305.2. So that's just going to be 54.8. That's your answer you would fill in. There's no other work that you have to do for this. All right, let's look at the top of the next page, question number 4. Here you have a quadratic equation. It has technically two constants in it, p and w. And you're also told it has one real solution. They want to know what is the value of w have to be. Okay, so if you're going to do this by hand, what you would basically do is you would have to get this equal to y. So that would mean py equals negative 4x squared plus 91 minus w. Then you got to divide everything by p. Since this is just one number, I'm just going to make one fraction. Okay, so now it's in the form of y equals. So again, to find a solution, that means that the y value is 0. So now you can use the discriminant. In other words, now you can do b squared minus 4ac, and because there's one real solution, you set that equal to 0. So in this quadratic now, a is negative 4 over p. B is technically 0. There's no x term. C is the 91 minus w over p. All right, so b squared is just 0 squared minus 4 times negative 4 over p times 91 minus w over p. And again, this whole thing is equal to 0 because there's one real solution. All right, the 0 squared just drops out. I'm going to multiply this negative 4 times negative 4 and make it positive 16 over p. Notice there's two p's on the bottom, which make p squared. So I'm going to multiply both sides by p squared. And technically, that means that p is irrelevant for this. Also, on the right side, notice you still get 0. So now we get 16 times 91 minus w. Technically, you could distribute this, but you actually don't have to. You can actually just cancel out the 16 and divide by that. And you still get 0. So now 91 equals w. So that's it. That's your answer. And you could go into Desmos just to confirm this. I'm going to type the equation. Okay, I'm going to set w equal to 91. Now, p technically will not matter, and I'll show you why. Because notice what's going to happen is when I slide this, notice it's just making it wider and narrower, or it flips it from opening up to opening down, but there's one solution the entire time. It's touching the x-axis at one single point, technically at the origin right here. So the p-value is irrelevant for this, okay? So this just confirms that the answer is w equals 91. All right, now, the way you could do the entire problem in Desmos is the following. you have to basically first take this quadratic. Again, you're going to have to get it in the form of y equals. So you're still going to have to do the initial work that I did using the other method. You're still going to have to do this first, okay? Then you're going to take the right side of it right here, and you're going to do regression, and you're going to do regression to its vertex form. And when you do that, well, I'll show you what we're going to do. So we got negative 4 over p x1 squared plus this. We could just make a giant fraction, 91 minus w over p. Okay, now we're going to do vertex form, which is x1 minus h quantity squared, but I'm not going to put a plus k because I want vertex form, but I want the k value, the y-coordinate of the vertex, to be 0. That will guarantee one solution. Now we have to add our element list for x. Okay, notice here we are getting the correct value for w of 91. So this is how you can do the problem entirely in Desmos. Now, if you want to know more about this technique, in other words, about how to basically do regression of a quadratic to its vertex form for when there is and when to use that for when there's one real solution, or you can also technically use it for determining when there's two real solutions versus no real solutions, check out my ultimate Desmos guide to digital SAT math. Let's look at the last question. This is problem number 10. This lovely diagram came to us from a person who recreated it and posted it on Reddit. So in this circle, we have point O is the center. You're told BD here is a diameter. Let me go through the center. That would make sense. And you're also given that AC and BC are the same. So this is an isosceles triangle. So, I don't know, like this side and this side are identical. The full side, not just, the part to the left of where it intersects BD, the full thing. Okay. Find the measure of DBA, which is this angle up here. So, we know that, first of all, we know this angle is 71, and we know this angle right here is also 71 because it's an isosceles triangle and you're told AC and BC are congruent or have the same length. So angles opposite congruent sides will have congruent measures. All right. Now, next thing we can figure out is that this is angle BAC right here is an inscribed angle. Its measure is equal to half the measure of its intercepted arc, which is arc BC right here. Another way to think about that is that the measure of arc BC is equal to double the measure of angle BAC, which is 71 degrees. So 2 times 71 is just equal to 142. So this arc has a measure of 142 degrees around the circle. Now, because BD is a diameter, that means that, from B all the way down to D, that entire arc is 180 degrees. Okay, so from here all the way up to here, 180 degrees. Therefore, DC, just pick a different color, right here, this arc will just have a measure equal to 180 minus 142. So that's going to be 38 degrees. So this is going to be 38. Therefore, angle DBC, which is another inscribed angle, is equal to half the measure of its corresponding arc, which is 38. So, and let's pick a different color, this angle right here, just the orange part, is going to be equal to half of 38, which is 19. Now, a lot of people on this question reported that their answer was 19. So that would seem to indicate that they wanted you to find the measure of angle DBC. But someone else in the comments said you were asked to find the measure of DBA. So I'm solving it as if you're finding the measure of angle DBA. But if you really were finding DBC, then you would be done. The answer would be 19. Okay. Now for DBA, there's one more step. You technically just have to do 71, measure of angle B, the whole thing, minus 19, the DBC, the small orange part. So 71 minus 19, that would give you 52 degrees. Okay, just for the blue part right here, 52. Still in October 2025. We are on worksheet number 2. Let's make sure I get the whole thing on the screen here. Problem number 10. This diagram, I just want to show a couple alternate methods you could use by adding some additional lines to the picture in order to figure out the measure of angle. Which one are you looking at? It's dBA. This angle up here, actually, this angle right here. This is what we are finding the measure of. Okay, so first approach. If you draw this line here, okay, then if you notice, angle BDC, this angle right here intersects this arc, okay? The measure of this arc is going to be twice the measure of its corresponding inscribed angle, which is the 71. So this is 71 times 2, or 142 degrees. That means that this angle down here will be half the measure of that arc, or in other words, this angle down here is 71 degrees. Another way to think of that is you have two inscribed angles intercept the same arc, therefore the angles are congruent. All right, so now that you know that this angle is 71 degrees, and you know that this angle is 142 degrees, let me just look at my notes here. BCD, okay. You also know that this angle is 90 because this angle here, this inscribed angle, basically intercepts a semicircle. Because BD is a diameter, which means this whole thing is 180. Therefore, this is 90. So you've got now 180 minus 90 plus 71. The third angle of this triangle is 19. And we know since AC and BC are congruent, this angle is 71, this whole angle is 71, therefore dBA is equal to 71 minus this 19, and it will be 52. All right, so that is one way to get it. The second way to get this, and let me just clear basically the entire picture as if we're starting from scratch. Okay, the second approach, if you draw this line here, which is a radius, this angle is 71 degrees. We already said that this arc is double that, so it's 142. That means, just make sure here, yes, should be OC. This angle right here is 142 degrees. So now, this angle COD right here, which is adjacent to 142 because they form a straight line, this is going to be 38 degrees. This is a central angle, which means it will correspond to this arc over here, which is 38 degrees, and therefore you will take half of this arc to find the measure of its inscribed angle, which is 19, and then again this whole thing is 71 because AC and BC are congruent, and 71 minus 19 is equal to 52. So this is an alternate way that you could go ahead and figure out the value of dBA as well. Go ahead and take a look at this first problem we have here. So for this one, this is the problem that dealt with the triangle where you basically know the measure of one angle. So we've got, x, y, and z, and we know that one of the angles is 32 degrees. The other two we don't know. We do know that x is bigger than y, and also that y is bigger than z, so these are both bigger than 32. That's all we know. And it says, which of these expressions is not sufficient, keyword being not, to identify the measures of all three angles in the triangle. Okay, so basically what happens with this problem is you first think about it and say, okay, x plus y plus z equals 180. All three angles in the triangle add up to 180. All right, but we know that z is equal to 32 degrees. So really, you have this equation, right? X plus y plus 32 equals 180. Now, what ends up happening is if you look at all these answers, okay, all of these answers are going to be equal to some number. Now, we don't know what that number is, so I'm just going to use a generic C for it. And basically, if you set them all up, so I'm just going to, in kind of like the same format here, so I'm going to put the 32s all under the 32, even though they're listed first, and then line up like the X and the Y terms. So I'm just going to switch the terms basically. This, and then for answer choice C, we've got 3x minus 3y, and then for answer choice C, we've got x minus 3y. Okay, plus, plus, and then these would just be equal to some number. I'm just going to, whatever, call it C for right now, some constant. Basically, the way to look at this is you have a system of equations. You have this first equation, or this first condition, which is that all three angles have to add up to 180 degrees. Then the answer choices are a second condition, or basically form a second equation, which is that each of these expressions is equal to some value or some number. So essentially, you to solve this, you would take the system of equations, meaning the top equation here, and then combine that with each answer choice, and essentially see, can you solve for the value of x or y doing that? For one of them, you cannot. For the others, other three, you can. So if you don't recognize it already, the answer for the one that is not sufficient is going to be letter B here. It's going to be this one. And the reason is because if you take the original equation and you multiply everything by 3, okay? So 3, 3, 96, 540, and then you add it to this one. Notice what happens is 3x minus 3x cancels out. The x's are gone. 3y minus 3y cancel out. The y's are gone. So all you end up with is basically 96 plus 32, whatever that is, 128 equals 540 plus whatever value the angles were given in, whatever value you'd be told. And notice that there's no solution here, right? So essentially, excuse me, what's going on here is this equation does not, this system of equations does not have a solution. Therefore, you cannot determine with specificity the exact values of x or y. Every other possibility, basically A, C, and D, you could. If you went ahead and like multiplied by 3, and then if you add like these two together, you'll notice the y's will cancel out, but the x's won't. And therefore, you could go ahead and you could solve for x. You can get a specific value for x. And then if you did the same thing with this one and this one right here, again, you multiply the top one by 3, and notice now the y's are going to cancel out. 3y minus 3y, and again, you could go ahead and add them and solve for x. And then you do the same thing with the last one, and again, notice the y's are going to cancel out, the original and answer choice D, so then you could go ahead and solve for x. So the correct answer to this one is going to be letter B. Now, just to show you real quick in Desmos visually, like how this works or essentially why this works. So you take the original equation, which is the x plus y plus 32 equals 180. Or, I mean, whatever number you had for the measure of z. That part is essentially irrelevant. Okay, so there is that equation. Now we go through the various answer choices, and what you have to do is you just have to pick some random number to set them equal to. Now, through testing, I determined that if I picked numbers like negative 300 and positive 300, then they would work out nicely such that you get values for the intersection points that make sense, meaning that they are, less than 180 degrees. In other words, if you set this number equal to like this, down here you get an intersection point that has a negative value, which you cannot have for angle measures. I mean, technically you can have them for angle measures if you're talking about unit circle stuff, but you can't have them for angles in a triangle. Okay? So if you do something like this, notice, yes, we can determine, this is for answer choice A, by the way, we can determine the specific values for x and y. Now, technically, this would not be an acceptable answer because the x value is not greater than the y value. So really, maybe if I do something like this, okay, here, now it works. Now I have an x which is greater than y, and they all three of them together add up to 180, and so A is not the answer. Okay? Now, if you go through B, what you're going to see is the two lines are parallel, meaning you cannot find what x has to be and what y has to be, and it doesn't matter what value you choose on the right. So if I just go ahead and slide this, I mean, notice it's not really moving very much. I have to, like, basically bump it up here to much larger values. Notice here it's getting further away, or if I go the other direction, it's getting closer together. But they are never going to intersect. They are going to be parallel, right? No matter how large I make it, they will never intersect. Therefore, the value of expression B is not sufficient to identify the specific measures of x and y. And we can do the same thing with answer choice C. So like here, let's just slide it right here. Okay, 87 and 61, x is greater than y. Okay, that works. And then let's check answer choice D. Okay, here, 130.5, 17.5. Doesn't work because the value of y is not greater than 32. So I got to slide this down a little bit. Let's go here. 97.25, 50.75, x is larger than y, and y is larger than z. Okay, this works. We found x and y. It's not the answer. Okay, so that's just a little visual representation of how you could solve this problem in Desmos. All right, let's look at the second question now, the one with the colony of bees. So when you read through this question, it seems like a very complicated and complex question, but it actually is not that difficult, and I'll show you. Here is the way you can solve it. Basically, what's happening, to find the total number of bees after some number of weeks, whatever W is, right? You would say, okay, we start with 1,900 bees. The first 2 weeks, we have 90 bees per week. So we're adding 180 total bees. Then we're adding 135 bees per week. Now, it's not going to be multiplied by W because this doesn't happen until week number 3. So that means it's technically multiplied by W minus 2. Because, for example, if you wanted to find the number of bees after, say, 3 weeks, right, it would be 1900 start plus 180, first 2 weeks. And then for week 3, you would just add 135, right? Because there's only one more week to reach 3 total. That's why it has to be 3 minus 2, because 3 minus 2 would be 1, and then 1 times 135 would be 135. So this overall expression represents the total number of bees after W weeks. So now you go ahead and you basically, this is 180, this becomes 135W minus 270. You combine this all together, 1900 plus 180 minus 270, it becomes 1810 plus 135W. So again, that is the total number of bees that you have. But this question wants to know how many are there remaining to reach the goal of 3050. So all we're going to do is subtract, like 3050 minus the number of bees we currently have. That will tell us how much is left or how much is remaining. Or really think about it like number of bees that you have is this, and then you're just going to say you add x, that's the number of bees like remaining or needed. And then together those would equal the 3050. That's your goal. So if you rearrange this, subtract this whole thing to the other side, that's where I get the 3050 minus that expression. So 3050 minus 1810, if you go ahead and subtract that, it should be 1240, and then minus 135W. Let's just go to Desmos to confirm that all the calculations are correct. So let's get rid of this 1900 plus 180 minus 270. So first we have 1810. Okay, good. And then let's do, just put a giant parenthesis around that, 3050 minus that. Okay, 1240, and then obviously the 135W flips. So the correct answer here is going to be letter D. Now, you could also solve this using back solving. So let's go back to the example I was doing earlier where I said, okay, after 3 weeks, this is the number of bees I would expect. And I'm just going to do this on Desmos because it's going to be so much quicker. So we would expect there to be 1900 plus 90 week 1, 90 week 2, 135 week 3. So after 3 weeks, we have 2215 bees. If we need to reach the goal of 3050, how many more bees do we need? Well, 3050 minus that 22 whatever, just put it in a giant parenthesis, 835. So I'm going to go to the answer choices and I'm going to plug in W equals 3. And I'm going to see, wait, why am I doing this? I don't need to do this. I could just do f of 3. There we go. And I'm looking for the answer that gives me 835. Okay, so first one, not correct. What am I doing? I forgot to type the W there. There we go. 1900 minus 135W. That's what I want. I plug in 3. Not correct. Now let's check in the second. Let's check the second one. 1810 plus 135W. 2215. Not correct. Again, we're looking for 835. What about if I flip this? 1405. Still not correct. All right, let's check D. 1240 minus 135W. What do I get when I plug 3 in? Right here, 835. That matches the number of bees that I would expect based on doing the calculation manually without a formula. Therefore, using back solving, I have shown that the correct answer is the letter D. All right, next, and this will actually be the last problem on this video. So here we have a word problem. This is November 2025, worksheet number 1, problem 2. It's actually a very creative way to solve the problem, not something I would have come up with on my own. Okay, so before I actually go and show you the Desmos method, I just want to point out a couple things, right? So essentially, we have 1900 bees to start with. All right, and then it's increasing by 90 after week 1, and then 90 after week 2, and then by 135 week 3, 135 week 4, so on and so forth, right? Blah, 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 blah. Okay. Now, we're trying to reach 3050. So the number of bees remaining, or the number of bees needed to reach the 3050 is going to be the total number of bees subtracted from the 3050. That'll tell us how many more we need in order to reach that. So that's the premise, or that's the setup behind this Desmos method. So basically all we have to do is go into Desmos, and I'm going to make a table. First table is going to have my x1 is 3, where 3 is the number of weeks. This is x1 is the same as w. My y1 is going to be the following. So, how many bees are remaining after 3 weeks? Well, 3050 to start with. Okay, minus. I have 1900 plus 90 plus 90, and then plus 135. And then now I'm going to do another point after 4 weeks, where it's going to be 3050 to start with, minus the same 1900 plus 90 plus 90, but now I have to add 135 2 times. Now you can just do a basic linear regression, and notice it gives us the value for the slope for the y-intercept that corresponds to answer choice D, right here. Notice the b value 1240, you see right here, 1240, and notice the m negative 135. I mean, they're 3 of the 4 are negative 135. B is obviously wrong because we're subtracting, we're lowering the remaining total as the weeks go by. But this is how you could set up and solve this entire problem in Desmos. Next question, number 8. Here we have a quadratic equation. You're told one of the solutions is of the form m plus root n over 3. Find the value of m plus n. Okay, I am going to just first quickly show you how you could do this by hand if you wanted to. Then I will show you how to do this very quickly and easily in Desmos. So, by hand, of course, you're going to do quadratic formula. We got our a, we've got our b, we've got our c. So we're going to do negative 18 plus or minus square root 18 squared minus 4 times 3 times negative 26 all over 2 times 3. 6, negative 18. I'll just tell you because I already did it in Desmos, but I'll check it. The square root number should be 636. 636 divides by 4, and it turns into 159. 4 times 159. So the square root of 4 comes outside as a 2, and then we have a 6. Then you divide the 6 into both terms. Negative 18 over 6 is negative 3, plus or minus root 159. 2 over 6 becomes 1 over 3. Okay, notice here's m, here is n. Negative 3 plus 159 is m plus n. The correct answer to this is 156. Okay, so that's, if you want to do it by hand, that's how you could do it. Now, let's look at, and again, I save time here, obviously, because to do this calculation, you'd have to go to Desmos or punch it in on a physical calculator, right? So it's not quite as fast as I showed there. Let's say you could do this in Desmos. What I'm going to do is I am going to first type in the function. And by the way, the technique that you have to use on this, because there's two constants in the answer, this is in my Ultimate Desmos Guide to Digital SAT Math, specifically the section, the video that focuses on quadratics. It's in a separate like 25-30 minute video that goes through some of the techniques of solving quadratics and like finding no real solution, one real solution, two real solutions, and those kind of things. So the thumbnail will be on the screen to show you which specific video that is. All right, now there's two ways we can do this here. The way that I personally prefer, which is actually more typing though, is to do a system of equations, and we're going to put in f of, and I'm going to first type in the given solution, which is m plus root n over 3. However, I have to use its conjugate, m minus square root n. Actually, do this. It'll be quicker to do it this way, over 3. Okay? And now I'm going to set up a system of equations because I know that both of those are equal to 0 in the function. All right, so what is happening here? I've got f of x. Oh, I typed x1s here. Why did I type x1s? This is not regression. You don't need to type x1s because of that. That's the whole problem. There we go. So notice, it gives me m, it gives me n. M plus n, 156, that's your answer. You know, it takes maybe 30 seconds, possibly 45 seconds, especially if you don't make a dumb typo like I did. Alternate way you could do it, which is quicker, you could also do this. You could put an x1 here, and then you could type x1 equals, and you make a list, and you put both of the solutions in the list. And put the fraction sign first, and over 3. Okay, wait, no, hold on. Let me just double check. Maybe we don't want the, maybe we don't, no. x1 equals, okay, why is it given me, oh, okay, never mind. Just remember, this is how we have to do it. We have to take the function, we actually have to do regression here using this method. You have to take the function, you have to regress it to 0, and then x1 down here is a list, an element list, and in that list are the two different solutions, the given solution and its conjugate. There we go. So this is the approach you have to take if you want to enter it in this form. It's a little bit different than the other form where I just entered it as a function and did a system of equations. This is technically a regression statement and then an element list where the element list has the two solutions. But it still, notice it gives us n plus n. Correct values right here, n plus n, 156. So this is an alternate way to type it in or to approach it if you want. I prefer the first method, but either way is technically fine. Being said, let's go ahead and start this November 2025 Digital SAT Math official test worksheet number 2. Okay, so the first question here is the resistor question that a lot of people were mentioning and talking about after the exam. So you have this equation. It's about these two resistors that are set up in series. If you're taking physics, probably familiar with that. If you have not taken physics, then don't worry about that. It doesn't have anything at all to do with the problem. Basically, it wants to know, okay, what's the positive difference between A and B, and A and B represent the individual resistance in ohms of both of these two types of resistors. Okay, so here's essentially what's going on in this problem. First, I'm going to separate the two terms that are being added on the left to write them like this. X times 1/5 and Y times 1/9. Okay, on the right side, we just have a number, 47 over 45. We keep that. All right. This over here on the right side is ohms. That's the unit that you use to measure resistance. All right, so that means that these entire expressions here, this has to be a number of ohms. This right here has to be a number of ohms as well. Okay, X is the number of resistors. So the unit on it would be just, resistors. How many you have? 5 resistors, 10 resistors, whatever it is. Same thing with Y, okay? The unit on it is resistors. Now, you're multiplying that by some number, 1/5 in the X case, 1/9 in the Y case, and that value is basically going to have units of ohms per resistor. And the reason is because when you multiply these two things together, the resistors will cancel out and you're just left with ohms. And that's what you want. You want this whole entire expression to be ohms. You want this whole entire expression to be ohms. Ohms plus ohms equals ohms. Therefore, A, which represents the resistance of an individual resistor, which would have a unit value or a unit of ohms per resistor. And similarly, B would have a unit of ohms per resistor. Those are going to be represented by these fractions right here in the problem. So in other words, the 1/5 is equal to A. The 1/9 is equal to B. So the positive difference between them is 1/5 minus 1/9. Now you could just go and do this in Desmos, or you can get a common denominator of 45. It's going to be 9 over 45 minus 5 over 45, and that equals 4 over 45. Correct answer for this one is letter D. Okay, so that's basically how you work this problem out. All right, for the next question, this was another common problem that came up. There was a kind of like there was a similar problem to this that came up last year. I think it was I want to say it was in May, maybe possibly in June. But that one was a little bit different because that one you were given one function and then you were given two other new functions which were equivalent to it. This one, you're just given two different functions, some information about them, and you're asked, which of these displays the minimum value of the function as a constant or coefficient in this specific domain of basically x greater than or equal to 0. All right, so I think the easiest way to do this is to just visually go ahead and graph both functions. So go to Desmos, and then we'll just be able to work with specific numerical values and go from there. So f of x, the first function, a times 0.19 to the negative bx. Second function, g of x. Just go ahead and type that in. Little trick here, type the plus 2 first, and then put the x in. If you type the x first and then try to do plus 2, it like drops you down back to the main level, and you have to like go in and fix it and edit it anyway. So just a little tip there. And then add the plus b at the end. Okay, now we have to pick numbers for a and b. A is greater than 1, and a is less than b, which really means b is greater than a, if you want to think about it that way. So I just said, let's let a equal 1.2, and let's let b equal 2. All right, so now I have both my functions, and I'm going to do one other thing that I forgot to originally. I'm going to add the restriction that x is greater than or equal to 0 on both of the graphs. All right, so now I have my two graphs. So what is the minimum value of each of these graphs? So let's start with the red one. Okay, so the minimum value is clearly right here. It is our y-coordinate, 1.2. Okay, do we see that value anywhere in f of x, the red equation? And the answer is yes, right here. A is equal to 1.2. So A is a coefficient, that's in front of this 0.19 here. So right off the bat, for this one, the answer is yes. So we're looking at either A or C. B and D are both out. Now, we go down here to look at the blue one. Okay, here's the minimum value, 5.93132. All right, do we see that number appearing anywhere in this function? No. A is 1.2. B is 2. We have a 1.81 here. So I do not see that minimum value showing up anywhere. Therefore, correct answer to this one is going to be letter A. It's the top one only. Get started now. December 2025, Digital SAT Math, official test problem set number 1. Okay, problem number 1, this circle problem. Very common problem that I saw come up. So first, I will show you how to do this by hand, and then after that, I will show you how to do the entire problem in Desmos. So first, to do this by hand, here is kind of the theory behind this. All right, essentially, we're going to take the equation for circle A, and we're going to complete the square on it. Now, really, we don't need to do that just yet. Really, all we're trying to do initially is get the coordinates of the center. I'm going to move the 4n over to the other side and put 2 blanks here. So, if you remember completing the square, we take the b term and we take half of it, and then notice that's negative 3, and then we square it, and that number is what goes in this blank and this blank. And then we do the same with the y's. B equals negative 10, cut it in half, negative 5, square it, 25, 25. Okay, I'm going to come back to this right side later. Now, if you notice what happens, this is going to factor as x minus 3 squared plus y minus 5 squared. And that's because when you do completing the square, essentially, it's going to factor as x and then plus basically the b over 2 term that you squared in the parentheses. Meaning here, the b over 2 value is negative 3, so it's x minus 3. Here, b over 2 is negative 5, so it's y minus 5. All right, what that tells us is the center of circle A is 3, 5. That means the center of circle B is also 3, 5. They have the same center. They do not have the same diameter or radius. So what I need to do now is calculate the radius of circle B. We don't need the diameter technically. Like it says the diameter of B is twice that of A. You can just replace this with radius, okay? Radius and diameter are both one-dimensional, lengths. Therefore, if one is twice the other, then the other will be twice, the other circle. All right, so now I can calculate the distance between the center of circle B and this given point that is on it. Now, I'll show you how to do this in Desmos during the Desmos solution, but let's just say you're going to, if you're going to draw this out by hand, right? 3, 5, it's like right here. 2 to the right, up to 5, 7, it's right here. So we're finding the distance from here to here, from 3, 5 to 5, 7. So notice it's basically just 2 to the right, up to 2 squared plus 2 squared equals c squared, 4 plus 4 equals c squared equals 8. Therefore, c is equal to square root 8. So the radius of circle B, so this is the radius of B, is equal to the square root of 8. Notice, that is twice the radius of circle A. That means the radius of A will be half that value. It will be square root of 8 over 2. Now you could simplify this. You could make this 2 root 2 over 2. And really, the radius of A just then simplifies to root 2. Okay, so now that we have that, well, that just means that in the standard form equation, r squared, or the radius squared, is root 2 squared, which is just going to equal 2. Thus, we now know that on the right side, this whole expression right here that I was doing for completing the square, this whole thing must equal 2. So 4n plus 9 plus 25 equals 2. 4n plus 34 equals 2. 4n equals negative 32. N equals negative 8. That is your correct answer. All right, let's see now how you could do this in Desmos. So I am going to go to Desmos. And the first thing I would do is I would type in the equation of circle A because I'm going to do some circle regression. By the way, if you want to know how to do circle regression, check out my Ultimate Desmos Guide to Digital SAT Math. I will put the thumbnail on the screen for the specific video which covers regression of circles. I believe it's in part 5, advanced functions, but the correct video thumbnail will be on the screen. So just give me 1 second to type this out. So what I'm doing here is I am regressing. Oh, I forgot to put the subscript 1. Okay, I'm taking equation of circle A and I'm regressing it from its given form to standard form. All right, couple things. This is not quite correct because I need to put element lists for x and x1 and y1. Once I do that, okay. Notice, it's auto-filling a value here for n. That's not the correct answer to the problem, obviously. That's just a random value it's filling in. So we can just ignore that for now. But the important thing here is getting h and k equal to 3. Okay? In other words, what we know is now the center of the circle, I'll just call this like capital C, is the point 3, 5. All right, so next, and one other thing just to show you too, let me just slide this up to cover the problem for a second. You can set n to whatever number you want. Like right here, I'm setting n equal, and notice as I move the slider, the h and k values do not change. Okay, even if I go into negatives, h and k are not changing at all. So the center values it finds for the coordinates for h and k are correct regardless of whether you pick the n value or whether regression picks the n value. Notice they're staying fixed at 3, 5. All right, so now let's just get rid of that and let's go back to the problem. So next step, we got the center. That was like step 1. Step 2, we needed to find the distance between the center and the point that's on circle B. So in other words, I am going to now, I'm just going to call this capital B for the point that's on the circle, and I'm going to find the distance between those two. Wait, I just defined this as letters so I didn't have to type them all out. There we go. That is the distance between these 2 points, i.e., this is the radius of circle B. Now, remember, to get the radius of circle A, we have to divide this by 2, because the radius of B is twice that of A. Okay? Therefore, the radius of A will be half the radius of B. So I'm going to take this and divide it by 2. So right now I have this value is the radius of a circle A. So now all I have to do is I just have to set this equal to r, and that will feed this back into the original regression statement and find the value of n for this circle such that its radius is equal to this value, which if you recognize it, it is just the square root of 2. Boom. There we go. N is equal to negative 8, and that is your answer. That's how you could do this entire problem in Desmos and, in less than a minute. Again, basically all the steps, listed out here. The top of the next page. Here we have question number 4. We have a rational function. We're given 2 points. What is the value of b for this function? This, which is a constant. A is a constant, b is a constant. Okay, so first I'll show you how to do this by hand, and then after that we will go straight to Desmos. So let's look at this first thing. Okay, you plug in negative 33 for x. So it's going to look like this. Let me fix this a little bit. Now technically, I'm still going to write this out, even though the bottom doesn't matter. And then this is equal to 0. Because if you're trying to solve this, say, for a, if you cross multiply, this whole thing times 0 is just 0. So really, we can just ignore the bottom for this, for this purpose. In other words, if you have a rational function and you have an x-intercept value, that's really what this is. It's the point negative 33 comma 0. It's an x-intercept. The denominator is irrelevant, when it comes to rational functions and finding x-intercept values. It's really where does the numerator equal 0. All right, in any case, with all that being said, you should end up with, let me look at my numbers here. Negative 33 squared. It should be 1122. No, sorry. Yes, 1122. Let's just do the calculation in Desmos. Because basically, you move the a over and you get a equals negative 33 squared minus negative 33, technically plus 33. Tilde negative 33 squared minus negative 33. Okay, so it is 1122. Now, to solve for b, we are going to use the second point. Technically, we need to solve for a in order to get b, because if we use the second point now and plug that in, notice it's like 0 squared minus 0 minus a over 0 cubed minus 0 minus b. Okay, and this is equal to 33. If you didn't know a, you couldn't solve this for b. So that's why we technically have to solve for a first, at least if I'm doing this by hand. So notice these zeros all drop out. So we get negative 33b equals negative 1122. I believe b should be equal to 34. Let's just double check though. Okay, close this out. Negative 1122 divided by negative 33. Yep, positive 34. So what is the value of b? It is 34. Correct answer is letter D. However, we could solve this entire thing in Desmos, so let's take a look at how to do that. Make a table. Let's put in my 2 points. Next, type a regression statement. Now the denominator, forgot to put the 1 here. What is b? B is 34. There's our answer. It also got the same a value that we got. That's how you do it in Desmos. Took me 30 seconds. All right, let's look now at the bottom of the page. Question number 9, this extremely long guinea pig survey design problem. Okay, so you can read all the text there. I'm not going to bother reading all this text out. Basically, you're choosing some guinea pigs and some other type of rodent or animal from different habitats, and they study them, and they notice basically 2 things: that in early adolescence, the cavies, I don't even know what that is, were moved more across more squares than the guinea pigs. And it also found, but that's between a between species comparison. Then it also found for both species, comparing early adolescence to late adolescence, the virtual squares decreased, meaning more active as they were younger and less active as they were older. Okay. Which of the following statements is an appropriate conclusion? I'm just going to tell you first, the correct answer is D. In general, you can only generalize to the largest like area or place or thing that you selected the participants from. And that's assuming that you randomly selected them, which I believe is, it's what was listed in the question. So the point being, and I'll get to this a little bit more, I talk about point C, you can't take any results from the study and generalize it to like other guinea pigs in a different country, or even in a different part of the country, or a different habitat nearby, or something. You can only generalize it to the overall like area or thing that you chose the guinea pigs from. Again, I'll talk about this a little bit more when I get to part C and showing why that's wrong. All right, so part A, this difference in behavior between the two age groups, meaning like one was older and one was differences between early adolescence and late adolescence, whatever, was caused by difference in habitat. There's no way of knowing that or proving that. Or the only way you would be able to determine this is if you somehow controlled for all of the other factors in the experiment and basically isolated it down to that one specific factor, the difference in habitat, causing this behavior. But there's no mention of that in there, so this does not make sense whatsoever. Okay, part B. The difference in behavior between the two age groups was caused by aging. Okay, so meaning they get older, and as they get older, there's less movement or whatever. So yes, this is possible, but this is just correlation that they have noticed or observed. There is no proof of causation. And again, you would need to control for all the other variables or all the other factors to determine that the difference in behavior between early adolescence and late adolescence was caused solely by aging and not by, any other factor available. Like maybe during the study, I don't know, between when early adolescence started into late adolescence, something happened with like the climate, and I don't know, it rained a lot, or it was the temperature got significantly colder or significantly warmer, or, whatever, and like one of those, or there was a drought or something, whatever. Any of those things could have impacted the amount of movement um, between early adolescence and late adolescence. Okay, and that's not mentioned anywhere in the description or anything, so therefore B is not an appropriate conclusion. Okay, let's talk about answer choice C. So this is what I was mentioning earlier. Basically, excuse me. The difference. This is now comparing the difference between the different animals only in early adolescence. Like in other words, one crossed more squares in early adolescence, the cavies did, than the guinea pigs. Okay, and C is saying that this can be generalized to all guinea pigs and all cavies. You cannot do that. You can only generalize study results to the largest thing that you chose the participants from. So in this case, that is the habitats. You cannot generalize it to, like I said, all guinea pigs, um, you know, in the county or in the state or in the region or in the country or in the continent or, in the entire world or whatever. Because you didn't randomly select the participants from those larger areas, those larger groups of guinea pigs. It's another way to think about this. It might be easier to think about this in terms of, like, say, schools or a school district, right? So you want to do a study. You select, I don't know, 100 students at random from a school district. And then you go ahead and you complete the study and you find whatever it is you're studying. Something about homework, number of hours spent on homework, and like versus participation in sports or versus having a job or whatever you're studying. The results of that study can only, assuming that you randomly selected the students, can only be generalized to that school district from which all the participants were selected. You cannot generalize it to, say, other maybe other high schools in the same school district or the same county. You cannot generalize it to other high schools, I mean, maybe in the same city that are not in the same school district, or other high schools even in the same state, or all other high schools in the, United States in general. You cannot do that. You can only generalize it to the basically largest population from which the participants were selected at random. So the correct answer to this one is going to be letter D. Question now on this worksheet of new problems from December 2025. Question number 18, you're given an exponential function here. X represents the number of years since the account was opened. F of x, of course, just represents how much money's in the account. And it basically wants to know, like, which of these statements describes essentially the percentage increase in the money accurately. Okay, so you can do this in Desmos to check. I'll show you just how to do that, calculating percentage increase. The theoretical perspective is, okay, we take this number, right, this 1.005. This is exponential growth, so it's like 1 plus r. That means the r value is 0.005. That's the decimal equivalent of it, but as a percentage, r would be, you multiply it by 100, it would be 0.5%. Okay? So this is increasing by 0.5%, the amount of money in the account, every some time period. That's what we're going to figure out. So the point is A is wrong, right off the bat. Okay, because it has 0.005%. No, there would be like 2 more zeros in here if that was the case. All right, so we know it's 0.5%. The question is, how frequently does this happen? So essentially, you have 1.005 times 2 times something. All right, let's look at answer choice B. So if it's every 6 years, that means you would plug in 6 for this, for x, which means the exponent would then become 12, which means the $6,000, the original amount, is increasing by 1.005 to the 12th, which is some number larger than 1.005. That means the amount of money is not increasing by 0.5%, it's increasing by some, other slightly larger amount. So B is going to be wrong. Essentially, if we want a 0.5% increase, which is what all the answer choices we're left with are talking about, we need this. Basically, we need to be left with 1.005, and we need this whole exponent to equal 1. Okay? So 2 times something, this whole thing needs to be equal to a 1. How do we do that? Well, this has to be basically 1/2 or 0.5. But remember, this number represents the number of years, not the number of months. So in other words, if I'm plugging in 1/2, like in other words, half of a year, that is equal to 6 months. Now again, you wouldn't plug in 6, you'd plug in technically like 6 over 12 to convert months to years. So the correct answer for this one, it's going to be letter D. It increases by 0.5% every 6 months because 2 times 1/2, which is the year, the way you represent 6 months in terms of a year, 1/2 of a year, will cancel out. It'll make this a 1, and then you're just multiplying the 6,000 by 1.005 to the first, which is just 1.005. Okay, let me show you just how you could confirm this now in Desmos. So, percentage increase, the formula, the way you calculate it, it's basically new minus old over old, and then times 100 just to convert it to a percentage. So if we go back to Desmos now, what I'm going to do is just enter the function. Okay, and now I'm going to find, so for the first one, I'm going to find how much it increased over that time period. So f of, and now here's again we have to be careful. It says 6 months, but again, we're not plugging in months for x, we're plugging in years. So like, I'm going to take the 6, I'm going to divide it by 12 to get the number of years. Minus, and I'm just going to use like 0 months as my, old. And then divide that initially, multiply that by 100. So notice, when I plug in 6 months, i.e. 6 over 12 for x, I get a 0.5% increase. That corresponds right here to letter D. It does not correspond to letter A. And now what I could also do, I mean, you don't need to do this, but just to show you, for B and C, if I tried to plug in those values, so for B, I'm just plugging in just the number 6 because it's 6 years. Okay? Well, it's not a 0.5% increase. After 6 years, it's a 6.16 or 6.17% increase, so that's wrong. Now, if you wanted to do zero point 0.5 months, basically you have zero point 0.5 and then divide that by 12. Okay, this is like some ridiculously small 0.04 to 0.041% increase, not 0.5%. So both of these again are wrong. That's how you could confirm this. Just basically solve the problem entirely in Desmos. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are two versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants in the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.